Good morning, everyone, and thank you for tuning into the Zebra Mussel Forum. My name is Caitlin Anderson, and I will be co-hosting the forum with Colton Sorensen. We both work with the Polk County Land and Water Resources Department in Balsam Lake, Wisconsin, and are excited to bring you a full lineup of presentations regarding zebra mussels. The Zebra Mussel Forum is brought to you by a partnership between all of the entities on this slide. I wanted to take this opportunity to thank all of our partners for their contributions with the planning and promotion of this event. I would also like to take this opportunity to thank all of our presenters for sharing their expertise and making this event possible. And last but not least, I would like to thank Jake McKinven with the Polk County IT department for all of his technical support. With a jam-packed day, our goal is to follow the agenda as closely as possible. We have allotted for a 5-minute break around 10:35 and a 45-minute lunch break at noon. During the lunch break, we'll have a slideshow of photographs for your enjoyment if you wish to stay online.
Before we get started, I would like to cover a few housekeeping items. The forum will be recorded and sent in a follow-up email to everyone who RSVP'd to colton.sorensen@polkcountywi.gov. If you didn't receive or didn't RSVP with me, please do so by emailing me. And I will put my email in the chat right now. Okay, it should be there right now. If you are unfamiliar with Teams, there is a chat feature that you should now have a red notification indicating a new message in the chat. We will all be using the chat feature in Teams to ask questions, share information, and interact with speakers, as we ask everyone to remain muted with your camera off. Also, Caitlin will be adding presenters' contact information and any links from presentations into the chat. At this point, I would like to turn the forum over to Emily Moore with the Burnett County Land Services Department, who will be moderating today's forum.
Thanks, guys, and welcome to the Zebra Mussel Forum. I'll be your moderator today, and I will be introducing each of the speakers, and I'll also be moderating the chat at the end or during the morning session. So for our first speaker, we will be hearing from Maureen Kelscher. She is the Water Resources Management Specialist with the Wisconsin DNR, and she is going to be introducing us about zebra mussels and how they become established, their population growths and impacts in water bodies. So, Maureen, you have the floor.
Hi, thanks for the intro. Let's see. So I'm going to give you a 101 on zebra mussels, background, and next steps. I'm Maureen Kelscher with the Wisconsin Department of Natural Resources, and I'm also referencing my graduate research with the Wisconsin Cooperative Fishery Research Unit at UW-Stevens Point because I'm sharing some of the research I did when I was there. But currently, I'm the Aquatic Invasive Species Monitoring Lead for the state, so I give guidance to our lake, stream, and wetland biologists and the citizen programs on how to monitor for invasive species. And I'm happy to talk to you today about zebra mussels. So zebra mussels are truly the iconic invasive species. By definition, invasive species are non-native species that outcompete native species and have some kind of negative impact. And whenever you see anything about invasive species, you see this picture of zebra mussels. They're well known. They've made a mark and an impression on people. So this isn't the first time you've heard about them. Zebra mussels were introduced from the Ponto-Caspian region to the Laurentian Great Lakes. So they came overseas in the 1980s in ballast water. They took a hitchhike ride, and when we discharged ballast at the ports, they discharged zebra mussels. Then my next several slides show from when zebra mussels were first introduced, where they were found. This is 1989. In the upper left corner of the screen, it's going to show you the year, and I'm just going to click through them fairly quick. Oh, okay. You'll see as we go into the 90s, zebra mussels were spreading down the rivers as they were being reported. They're going from the Great Lakes and spreading outward. And then I think in 2016 was when they were found in Northwest Wisconsin. Before that, at least in the McKenzie Lakes in Washburn, Burnett County. So you'll see the dots start appearing there. But northern Wisconsin is still relatively like uninvaded by zebra mussel populations. So the communities there still have a lot of questions. I'm going to do a zoom in. I made a map with where the known locations are in Northwest Wisconsin, and about the years that they had been detected. So the Great Lakes in '89, and then some of those connected waters in the early '90s. But then you didn't start seeing them inland until say 2010 when they were found in Bass Lake, and then 2016 with McKenzie Lakes and so on, just for your local distribution. The things you hear about zebra mussels being that iconic invasive species are much what you see in the screen, where you see a blanket of zebra mussel shells along shoreline. This is in the picture in the Great Lakes, probably Lake Erie. Lake Erie is very productive and a favorable environment for zebra mussels. So you do see this, or did at least at that time, where it was just covered with zebra mussel shells. However, this is what we typically see in a lot of lakes. This is still likely even a Great Lake where the picture was taken. I think it was in Lake Michigan, where you see these dead shells of zebra mussel shells, but it's not a blanket like what you saw in the prior slide. And that's what we see in a lot of inland lakes too. Although don't get me wrong, like the zebra mussels are certainly there. It's just our outreach material has been more what you saw in the prior slide. I'm going to give you a little bit of background on zebra mussel biology, and this is a great graphic, and I'm going to walk you through it. So zebra mussels are regulated by temperature, kind of everything is that is in aquatic systems, where they're reproducing and they're growing and metabolizing between 53 and about 87 degrees Fahrenheit. Beyond those temperatures, they're just not going to be metabolizing. And if it gets too hot, they're going to cause deformities. Zebra mussels have males and females, so they are releasing eggs and sperm directly into the water column. And then the eggs and sperm like find each other and fertilization occurs. They're typically in the water for 3 to 5 days before fertilization occurs, and they're releasing a lot of gametes there, but they have a high mortality rate, but they're still reproducing a lot. Then after they release those eggs and sperm and fertilization occurs, they have these things that you may have heard the word veligers. Those are juvenile zebra mussels, which is just a shell that's floating around in the water that you can't see with the naked eye. You have to use a microscope. I inserted a couple pictures here. This picture, it's a black box with a little white dot and then a black X. This is what we see when we look in a microscope after we collect a water sample. We have to use a polarized lens. That's what we see when we say we have found a positive detection of a veliger. It's tiny and it's a little black X. And then after about 10 days, that little black X grows into something that looks like this. This is just the drawing of it, but this is an actual photo. Still so small. When you're talking microns, nobody's going to see that with a naked eye. They have to grow and get bigger for you to be able to see them. But when the veligers grow enough, they have this little protrusion, and you see it in the drawing, and then also in the photo, it's a foot. It allows them, they can fall out of the water column. All of this is happening just when they're floating in the water. So they just kind of go with a flow in the water at this point. But when they get that foot, they can fall down onto substrates that are available and then start growing that shell. And that's after about 10 days of fertilization. And then they settle down onto surfaces. They refer to as substrates a lot, onto rocks, onto whatever is available, if any wood, on just the ground, onto the sand and silt. They tend to really favor plants at this point because they're everywhere, they're more abundant, and it's a soft spot for them to land on. Zebra mussels typically live about 5 years, you hear in the outreach material. When I was aging zebra mussels, I found 8-year-olds at some of the lakes that I surveyed. So they can live for a long time. But the amount of reproducing that they're doing at 8 years, that's a lot of time for them to keep reproducing. So you should all know what zebra mussels look like. This is a picture of their characteristic D-shaped shell. It's 2 shells that come together like a clam. They've got one flat edge of it, so it has the D-shaped, and then they've got these striations on them, kind of like zebras. It's a hard shell. You can crush it with your hands. And they get up to about an inch long, but they start out quite small. You're talking microscopic and then a milliliter in length. But the adults tend to get up to about an inch. Zebra mussels have that foot that I mentioned in that diagram, how they start growing that. Not only zebra mussels have this, but native mussels, you probably have seen that where you pull them out of the water and they have this fleshy little organ that sticks out. That's the foot, and they can push with that foot to allow them to wiggle across like the sand or surface to somewhere that they would rather be, whether it's to get a better habitat that they can attach to or for food. And then they have these byssal threads, which I'm sure everyone's familiar with because it is what lets them attach to things. They're little hair-like protrusions that come out from between those 2 shells and allow them to attach to like your docks, to wood, to rocks, or as in the picture is a native mussel. And it attaches firmly. It's almost cements itself, but then it can detach whenever it wants to move to a different place. And then here's a picture of what the zebra mussels look like. And you've probably seen this if you've been in a lake with zebra mussels, that they coat the bottom of rocks and go into the nooks and crannies just to have protection from wave action and vulnerability to predation, to be out of the sunlight. And then I referenced that they move around to look for food. They filter food, and you've heard how they filter water. And this is how they do it. They've got these straw-like projections that come out from in between their shells, and they'll just be sucking water into them. And they use those cilia even to bring the water and particles in to feed and to eat. They can filter about 1 liter of water per day. They select for certain plankton, so little organisms, and then for material, just for food, like they can tell what they're eating. Those little cilia will feel out what they're eating. It's difficult for them to feed if there's high levels of particles. So if you have a lake that's really tannin stained and just a lot of stuff in the water, it's hard for them to eat. They're not going to do as well. So they pick out what they want, and they can reject things too. They don't like to eat diatoms for whatever reason. It's probably more abrasive to their systems. And they don't like detritus. And they reject it out as pseudo feces. So feces is like excrement, but pseudo feces is when the zebra mussels will coat it in a substrate and then reject it. And then we call it pseudo feces, and it goes to the bottom of the lake and actually creates habitat for other things when they do that. But some of it resuspends as just particles and plankton in the water column. Then I have an image that explains that, where you see zebra mussels. We have a cluster of them on the bottom of a lake, and they're filtering the stuff out of the water, and then they're disposing some of that as pseudo feces, but then some of it mixes back into the water. But then you're creating habitat that's actually really good for macroinvertebrates. We'll see an increase in macroinvertebrate diversity in lakes following zebra mussel detection. And it's not just zebra mussels that do that. A lot of other invasive species do that, where it's good for macroinvertebrates, which can be good for fish that eat macroinvertebrates. but since they're filtering other things out and eating them, then it's taking some food out of the water column for planktivorous fish. But regardless, like what zebra mussels are doing is a net movement of energy is from the water column to the bottom of the lake. So it's going to be bad for some things that need that in the water column, but good for some things that live in the benthos of a water body. They cause alterations. So you hear that they increase water clarity, but that's altering habitat and doing other things. And I list just a few pros and cons here. For pros, they're increasing plant diversity because the water clarity, like you have clearer water, so the sun is now able to shine to deeper depths in the water. And plants can start growing where they hadn't grown before, and then it's going to create germination of plants that didn't have sun before. So you might start seeing new species of plants, and that's why they have the increase in plant diversity.
Hey, Maureen, sorry
Yep.
to interrupt, but could you turn your video off? Your slides are not changing in sync,
Oh,
and your video is a little laggy too.
yeah.
Sorry to interrupt.
No, I'm glad that you did, and I'm sorry, I'm sure that was distracting.
No worries.
Yeah. I hope that helps, and feel free to interrupt again. So the increase in macroinvertebrates I referenced in the prior slides, how like the pseudofeces are really good for macroinvertebrates, gives them more habitat and more food. And then it can cause oligotrophication, which people like. Everybody wants to have a clear lake, right? I also have that listed as a con. So with cons, I have that it decreases diatoms and plankton because you're taking things out of the water column, and that's going to take food away from other things that would have used them, and then also extirpate those species from the lake. And it competes with fish for those things that they're eating, and the fish would have otherwise ate. Also competes with unionids, so that's native mussels, for the food and also for space. And then they also smother the native mussels. And you'll see like a big die off of native mussels following zebra mussel introduction. But then it can cause oligotrophication, which is, even though it's a desired water body to have, it's opposite. It's going backwards in the natural progression of how a lake should be. Like a lake should naturally become a little more eutrophic over time, not become more oligotrophic. So that just cascades in an opposite way of what would have happened naturally. Then you hear a lot about algae too, or you may have heard about this. The zebra mussel presence can lead to blue-green algae dominance. Zebra mussels, how I said, those little cilia can filter out and certain things that they want to eat over others. They even do that with algae. They prefer certain types of algae over others. They do not like blue-green algae. It's something that clogs up their siphons and stuff, and they tend to avoid it. And if there's other algae present, they'll eat that algae. So when they're eating other algae and not the blue-green algae, it's actually making more room for blue-green algae to dominate, because you don't have that other algae because they've eaten it. And they have seen that, and there is research on that documents this happening. Wisconsin DNR doesn't have it. We haven't actually been able to do that analysis because we don't have enough data on the algae blooms to make any correlations. So we say that in the literature, and that certainly it's been there, that it has happened. We just don't have the data to be able to say that. And there's lots of other confounding factors that might be causing those algae blooms, like lake level fluctuations, aging septic systems, shoreline use, heavy rain runoff events, boating, and just other turbulence, et cetera, et cetera. There's lots of things that are impacting lakes. It's not going to be just zebra mussels, and we can't strongly say that this is what happens in Wisconsin lakes. And it's important to mention here that zebra mussels do have habitat limitations. They need a certain amount of calcium in a water body in order to build their shells. We do have water bodies where we've detected zebra mussel presence. and then we don't see them again. And the reason we don't see, like, we'll get a positive detection of the veligers looking through the microscope, but then we never see a population. And that's because there's not enough calcium to be able to support the shell development and just the functions of what they need to do to be able to survive. So we know that not all lakes can get zebra mussels, and it's based on calcium, and it's about 10 milligrams per liter. In UW-Madison, Center for Limnology has a suitability mapping tool that they developed just over 10 years ago. And I have a link to this, and you guys will have it as well available following this presentation. But here's a screenshot of what that looks like, where they've kind of mapped it out for the whole state of Wisconsin, what waters are suitable for zebra mussels. It's really great to be able to pan around. You can find your lake to see, is it suitable or not? And I want to point out here in the legend that they've got 3 different colors. They say suitable, borderline, or unsuitable. Those borderline suitable lakes, they shouldn't have a different category. Like, they're still suitable. The borderline suitable has a lower threshold of calcium, but some of our highest density lakes fall in their borderline suitable category. So from what we say, if it has 10 milligrams per liter, it's suitable. So ignore the borderline and just consider them suitable. But it's still helpful to know that, like, some lakes just are totally unsuitable. They are not, well, I mean, with change over time, what's happening in lakes, they could become suitable, but for what we know now, like, those lakes are not suitable for zebra mussels. But in areas where they are, like, a lot of lakes will be suitable. So this is where my personal experience comes in. Zebra mussels were discovered in Florence County in 2010. I was a county coordinator, a invasive species coordinator back in 2010 when zebra mussels were found. And that was the year after those maps were developed by Center for Limnology. So I'm looking at this map in Florence County and all our lakes are red. And I'm thinking, oh no, what if zebra mussels show up? And then the following year they did. And there were so many concerns about what to expect. And a lot of people had a lot of questions, like, what does this mean to my lake? This is my lake, my precious lake. This is where I live. This is the lake I fish on and I swim in, and, like, all my family, like, we all love this lake, and I can't believe that there's zebra mussels. What's going to happen? And the community was devastated, really. So we had a lot of questions, and we thought, well, what can we do to learn from this to maybe help others? So here's Florence County. It's northeast Wisconsin. It's an hour east of Eagle River, right on the border with the UP. And here I have the city of Iron Mountain. And we had zebra mussels around. This was Kai's Lake where they had just shown up. And then there were these lakes, random lakes within the UP that had zebra mussels. So we just knew that it was a matter of time. And then all of these little lakes all around here are red. And this is pretty similar to what we see in Northwest Wisconsin. Here's Spooner. And when you zoom in, you see, like, a lot of these red lakes, a lot of, like, that orange yellow that are also suitable, and then some blue lakes. And then here you've got, like, the red dots are where the populations of zebra mussels are. So you guys are experiencing what I did 10 years ago. And we back then thought, well, since we know all these lakes are suitable, maybe we can do something to figure out, like, where within these suitable lakes should we look, and what are populations in each of these lakes doing, and does it change over time? Like, what can we expect? Like, we know they're probably coming, but, like, and we know that there's prevention that we can do, but it's like, what's actually going to happen with these lakes that could get them? So we developed a project and put in a grant through the DNR grant program to get funding for a graduate student to answer some questions, to some of these questions. And I became that graduate student to do that. So these were my study lakes, and the study lakes that we had, there were 8 lakes that had zebra mussels detected from 1999 to 2012. They varied from 90 to 2,500 acres. So they're all very different sized lakes and different depths, from 25 feet to 200 feet. Like, these lakes weren't great to compare against each other, but we thought, well, we'll still see what we can learn and what each population is doing, because each had a different year spanned out over just over a decade. And we thought this could be a learning opportunity for what to expect, regardless of how different the lakes were from each other. We use scuba diving using quadrats along transects. We identified 12 evenly spaced points around the perimeter of lakes. And then we'd go out and run a transect and put our quadrats evenly spaced along each of these transects and scuba dive. And check out what's in each of those quadrats. The quadrats were just these square PVC frames. We would measure the depth, the substrate. So the substrate's like what is there, sand or rock or wood, and what are the zebra mussels using? And then we'd look at the zebra mussels themselves. We collected from some of those quadrats the zebra mussels to do some of the population dynamic estimates. I'm just going to share some of the data with you guys. The habitat results was a big surprise for what we learned. But I'm still going to share that with you because it's useful to know. Across the y-axis is the substrate type. So like what was there within those frames. We looked at silt organic material, which is going to be when you have the detritus, in a bog, you've got little bits of plant or little bits of wood, just little things. Sand, rock, wood, shells, and macrophytes. That macrophytes are just plants. I wasn't able to just change that word because I pulled this off of a picture. And then we looked at the relative frequency of each of those things within that square frame. So we'd estimate, well, about 10% of this is sand, 50% is rock, and the rest is macrophytes, something like that. We would just make those estimates, and then we'd say, well, what are zebra mussels using? So it was just a presence absence on each one of those types of material. To interpret this data, we've got two different bar charts. Availability is the white one. So that's what we saw when looking in those PVC frames of what was available for zebra mussels to use. And then the darker bars are what they were actually using. This data that I'm sharing is from all 8 study lakes combined. They were pretty similar, even though the lakes were so different in like size and depth. What we saw for habitat available across the lakes was it's pretty much the same. When you look at each of the lakes habitat charts, they were the same, and it's probably similar in your part of the state too. See, and then what they're using. So like a way for us to look at what they're actually selecting for is to look at a log scale, which you don't need to bother knowing what that is. The part to pay attention to is we did something to the data, those bar charts, and then we added an error bar. So for these substrate types where you have the error bar that falls below this line is what made it into a log. They're selecting against that. They're avoiding those habitats or those substrates, surfaces, and where the error bar is above it, they're selecting for it. And where it crosses this middle line, they're not for or against it. And what's interesting here is with plants. So the macrophytes, if you remember on this prior slide, there's a ton of macrophytes, and wow, are zebra mussels using them? But then when you look here, they're not doing it on purpose. They're just using them because they're present, because they're easy to fall on, because that's where they were. They're not selecting for them, but they are selecting for the hard stuff. So the rock, wood, and shells. Most strong for the wood and for the shells, which makes sense. Wood is good for everything in lakes. Fish really like the wood too. Same with the shells, like having those different structures. Also, the wood and the shells are easy for those zebra mussels byssal threads to stick onto and hold onto. So it makes sense. Those things are good, like wooden shells are good for other things in lakes, so they would make sense that they're good for zebra mussels too. But the habitat part didn't actually teach us any more than we knew, other than they really, really like the wood and shells. For growth, we saw differences across lakes. So to interpret this data, I'll first explain the axis to you and then the legend. But we aged the zebra mussels up to year 8, and then we counted how many were at each of in those age classes. Then we also measured them in those age classes with how many there are within that age class at that length. And then we could develop these growth curves for them. And then I put all 8 lakes. We only had enough data on 6 of the lakes that we actually did the analysis for. So all I share on these are 6. Some just didn't have enough zebra mussels. I've ordered them in the legend here in order of the oldest, which was Matanga, down to the newest, which was Kai's at that time. Matanga was in 99, Antwine in 2001, Naka Bay in 2006, Chicago in 2007, Moon in 2007, and then Kai's. And I've ordered them in the colors, kind of using Roy G. Biv as a rainbow, because that's something that we recognize with that color. And I was hoping that, well, the older invaded lake should be doing something that's stronger because they've been there longer than the lake that's newer. And that's not what I see. When I look at this, I didn't see that I don't see this pattern with the growth curves here. So there's something else that's occurring. All I know for sure is that when we run the analysis, we did analysis to do a comparison to see if each of these curves is different from the mean curve, and they were all different significantly. So we knew that the zebra mussels are growing at different rates in these lakes, and we know that they're growing fastest in Kai's Lake, the newly invaded lake. But then when you look down the row here, it's like, well, this is Chicago, they've been there since 2007, and then there's Matanga, the longest invaded, right? So we couldn't make any rhyme or reason from the data for why they're growing different in these different lakes. But we do suspect that the habitat and the lake condition has something to do with it. But it's a question that has yet to be answered. And then we looked at the mortality in the lakes. And this is similar to that prior slide where we have the age classes. So if they're 1-year-old, 2-year-old, 3-year-old. And this is the log of the frequency. So that's like how many animals are in these different age classes. And I use the same schematic with the legend with the Roy G. Biv for the oldest to the youngest invaded lake. And we do an analysis here to look at whether they're dying at different lakes or at different rates in each of these lakes. And to do that, you look at the slope of these lines, like how, if they're all at the same angle. And there are ways you can look at this to see if those slopes, how that curve, the diagonal line, if they're actually different from each other or not. And the most interesting thing about our study here was that there's no difference in how they're dying in these lakes, regardless of how long they've been there and regardless of how different the lakes are. The zebra mussels in these lakes were dying at the same rate. Another thing to point out is that where these lines cross the y-axis are what the annual recruitment is. So the number of new zebra mussels coming into the lake at that time. Where this crosses here. This is the log frequency. If you do the opposite of that, make it not a log frequency, it tells you what the annual recruitment is. And the highest annual recruitment for these is about 250,000 zebra mussels. So in Matanga Lake, where it crosses up here, each year they have 250,000 zebra mussels being recruited into the population, which is kind of a lot. So the populations just continue to expand over time. So we know that they're dying at the same rate. The numbers are just increasing. But they're growing different in these different lakes. So what our research study showed us that habitat selection is occurring and it's doing what we thought it was doing. The growth is varying among lakes, which does make sense, but we're not sure why. I need to look in it further. And mortality was not different among the lakes. And I want to mention too, we actually did those same analyses similar on the Mackenzie Lakes in 2018. Jeremy Bates was the regional DNR person at that time. And folks that he went out with, I helped them, went out to use snorkeling and scuba diving to assess the zebra mussel population in Big and Mackenzie Lakes. I wasn't able to help them do the full analysis that we looked at because we did the data different when we collected it. But we do have some interesting counts that I thought would be worthwhile to share with you guys for the ages of zebra mussels in the Mackenzie Lakes at that time. So in 2008, and the Mackenzie Lakes, I believe it was 2016 when Big Mackenzie was discovered. So these are the numbers for the Big Mackenzie Lake. We counted how many were at age 0, and there were about, well, age 0 was mean it was born just that year. There was just over 100, and ones that have been there for 1 year, there were about 150. 2-year-olds, there were 50. 3-year-olds, there were 4, and 4-year-olds, there were 2. So we found zebra mussels in Big Mackenzie in 2016, and we found 4-year-olds, so they'd been there at least since 2012, likely a little earlier than that. And then we measured the different lengths at them, which you would expect the bigger zebra mussels, or the older ones, are going to be a little bit bigger. So we still want to know is that why do zebra mussel growth rates vary among lakes? What is it about some of those lakes where they can grow faster? Probably has to be with how easy it is for them to eat or not and what food's available. And do zebra mussel growth rates affect the lakes? Like if they're growing faster, does that mean that are they having bigger impacts on the lakes? Because they're going to be siphoning more, removing more things, and depositing more feces to the bottom of the lake, providing more for the macroinvertebrates. And then what is that doing to the native species? Like we should be doing some kind of a comparison over time to see what the trends are. What are the impacts to the fish community, the macroinvertebrate community, to water quality in general? These are things that we should be looking at that data to see if there's anything we can tell from the data that we have now, or if there's something we need to be collecting just so that we know how these lakes changed. To start, DNR and Citizen Lake Monitoring are working to develop these tools, and I think some of you are piloting some of it where you're using the substrate samplers, and we're trying to make it easier to be able to assess the densities within the lakes to see how that changes over time. Like we're literally piloting it now. Last year was the first time we talked about it, and there were just 2 volunteers in the state maybe doing it, and now this year we're going to be doing a bigger push for it. So I encourage you to get involved with that. And I think Paul's going to talk about it later too. But now the DNR is identifying long-term trend lakes to assess zebra mussel populations and native species and water quality, just to be able to answer those questions so you guys will know like what is actually happening in Wisconsin lakes as it pertains to zebra mussels. We might have some existing data sets, and then maybe we could work on collecting more data just to see what's actually changing. I need to make a lot of acknowledgments to the folks that have done all this work out in the field, and then the people with my graduate research. I feel like that was a lot of information and it was a little bit heavy, so I'm sure you guys have questions. I have my contact information listed, but like I think we've got a ton of time. I'm not sure. Maybe we can take questions.
Yeah, nice job, Maureen. We do have some time for questions. We do have one in the chat. Marty Noonan was wondering how you determine age of the zebra mussels.
Yeah, you can feel it. They lay down growth rings, so they'll be growing all summer long when it's warm, and then you get that cold snap of winter, so they stop growing. And then in spring they start growing again. But when they stop growing, they leave like an edge where you can feel with a fingernail. My fingertips aren't sensitive enough to feel it, so you can look at it with a hand lens or a microscope to see it. Some people that knit tend to have really sensitive fingertips and can feel where the growth rings are. I hope that helped answer your question.
Let's see. Aaron Temple asks, back to the Big Mackenzie slide, what age classes did they find in the lake in 2018 when they were first discovered in the lake?
Oh, we didn't look. I don't remember. I'd have to look into our database. I don't know if Tyler's on the call and could maybe look at that, but they might not have aged them at that time. I'm not sure. Probably it was 1 or 2. That's a good question.
Okay. Dale was curious who we can contact regarding the long-term monitoring trends. And that he said that we just discovered zebra mussels in Balsam Lake last summer.
Oh, sure. I would contact your regional CLMN coordinator. It would be a good place to start, and then maybe the regional DNR AIS coordinator. So I think, is it Chris Larson for the regional CLMN person, and then maybe Tyler Masalk for the regional DNR. They would both be very familiar with the trend stuff and be able to help you get started. Please correct me if I'm wrong on the names, anybody.
Chris Larson has retired.
Yeah, Chris Larson retired from this area.
Oh, okay. I'm not sure who the person is.
Yeah, I don't know if that position's been filled yet, but
okay.
Maybe Tyler or some other AIS regional coordinator could get back to Dale. I can write that note down so I remember.
I can jump in real quick on that question. Chris did retire. There is an LTE in the office that's sort of filling his position in the interim while they look for somebody else. But if you're interested in Citizen Lake monitoring, you could also work with Colton and Caitlin to get set up for zebra mussel monitoring. That might be the best route to go right now.
Yeah, Paula, that's a great suggestion because I lean on those two a lot too, actually.
Perfect. The next question is from Rick. He was wondering, is the water used to transport bait in buckets susceptible to transferring zebra mussels? Is the water?
Yeah, the villagers could live in that water. That's why it's illegal to move water between lakes. One bait, one lake, and you should dump the bait bucket in between.
If I didn't say your question correctly, Rick, you can unmute yourself. It was just a little confusing, what you wrote down. So if that didn't answer your question, you can unmute and ask, but.
No, it addressed my question. Thank you.
Yep.
I was just wondering, is it transported via live wells in boats and bait buckets? And, I think I know the answer to those questions. It seems like just asking people to follow the rules has not been sufficient.
Yeah. And granted, they do have the juveniles have really high mortality rates anyway. They're in the 90s, but there is a law for a reason. So I think it's working on promoting that and why. Good question.
That was the last question in the chat. Feel free to keep asking your questions because we do still have plenty of time. Otherwise, because we have so much time, if you feel confident to unmute yourself and ask Maureen a question, feel free. I guess I have a question, Maureen. The Big Mackenzie Vellager toes that we've been collecting have been decreasing in concentration. Do you know why that is? There's just their numbers are lower than previous years.
That's interesting. No, I don't know. And I haven't looked at that data at all to know, like, I can't answer it. Yeah.
Okay. Yeah, because Middle Mackenzie is increasing now, but Big Mackenzie is decreasing. And I can send you that data. The Wild Rivers Conservancy collects the Vellager toast on both of those lakes, and we just noticed that there was an increase and decline in the lakes. So we thought it was interesting, and I don't know why.
It could be a boom and bust. I mean, the zebra mussel populations will like expand, they'll skyrocket, and then they kind of reach their carrying capacity for the lake, and then it'll just fluctuate a little bit, but then they'll be stable and not necessarily go down. But you could,
Okay.
I mean, because it's not even been 10 years, right?
Yep.
So they're still figuring it out. Maybe I don't know what it looks like on the Mackenzie Lakes. It's been a while since I've been out there. I was out there in 2018.
Sure.
Are they
Okay.
everywhere?
Yeah, I think Sandy's on, Sandy Swanson. She's the president of the Lake Association. I think when they do the plate samplers, that they're caked on there.
Mhm.
We do have some more questions. So Jeff asks, how do we find the map showing what lakes are suitable for zebra mussels? So Jeff, I did actually put that link in the chat. Up above, I can resend it though, but here you go. I did have that in there. Marty asked, what makes a lake unsuitable?
And not having enough calcium is really the thing, is that they just has to do with the bedrock, like how much calcium is in the water. And it could change over time. And you can get your water tested. I know that gosh, I think it was Lisa Burns. Was that you went and tested some of your lakes to see what the actual calcium concentration was? It could change over time, but a lot of it's tied to what the bedrock is, and you can't change it.
Marion asks, how does alkalinity in these lakes affect zebra mussel recruitment?
It's the same thing. Alkalinity tells you what the calcium concentration is. There's an equation actually through this website. There's something when you go to this website, it's just a screenshot of the website, but in the drop down, there's somewhere where you can get more information for how that was developed. They have an equation for how you can take conductivity to estimate what calcium is. And that's what they primarily use to develop this model, because we don't have calcium data on all those lakes, but we have the conductivity. Conductivity is similar to what calcium is. Calcium creates the conductivity. So they're kind of the same thing.
Okay. John asks, what occurred over the last 19 years in Florence County? Further spread of zebra mussels?
Yeah, they're in more places, but they're not everywhere. But they're in other lakes. I think there's about 50 lakes with public access in Florence County. I'm not sure how many have zebra mussels now. I know it's not a ton that have them, but there has been some spread. It's a connected system too, so the next lake downstream got zebra mussels. And then some other water bodies within the county.
Okay. Thanks, Maureen. We do have a two-part question from Dale. His first part is the DNR doing research today to understand lake conditions that can slow population growth? And what's being done in other states to understand this?
So we're just now talking about evaluating what lakes we could choose for a long-term trend. To see what's actually happening over time and to see what other things are impacted. And what's different about those lakes for why some are growing faster or slower. We probably don't have the capacity to look at that, but we have a grant program that someone from a university could apply to help answer that question. But we can at least identify the trends of what's happening in these water bodies with the zebra mussels themselves, and then also look at trends for like the fish and macroinvertebrates to better understand it. I don't know if I fully answered the question though.
Yeah, if you want to unmute Dale, go ahead if you need more clarification.
Oh, he asked about other states. Yeah, there was some research in other states through the Minnesota Invasive Species Center. There's efforts done, but I don't know that they're as much with looking at impacts to populations or how to reduce them. There's a lot of research on zebra mussel control. I think Angelique is going to go over that, how it hasn't been terribly effective, if at all. But I'd have to dig closer to see if other states are looking at what impacts are actually happening on these lakes and how the zebra mussels are, how zebra mussels are responding, how the natural systems are being affected.
Yeah, thanks. Yeah, your research was interesting. I thought it pointed to some potential variations in lake habitat that's causing different rates of population growth, and probably pretty ripe for some more research and understanding what you can potentially do to help limit the spread.
Yeah.
Yeah, and Dale, our afternoon sessions are a lot about control research, and Angelique, she's from the University of Minnesota, so I think she'll be touching on some of their research too if you're able to attend. Her talk starts at 1:15.
Thanks.
Our next question then is from Derek, and he was curious, are we only seeing zebra mussels in lakes both big and small, or are we seeing them in rivers and streams as well?
Both. Yeah, we see them in both. And rivers and streams, we don't look at as closely. Maybe zebra mussels are having a harder time staying attached because of the flowing water, but they're there as well.
Okay, thanks, Maureen. We do have another question from Aaron. Once the calcium in a lake is utilized to make their shell, does that calcium become reusable once the mussel dies? And then should these infested lakes be cleaned up of the dead shells?
I love that question. And I don't know how to answer it. One of the lakes, Lake Nakabe, I got scuba training for dry suit scuba, and like we went to, it was an interesting lake, but at the outlet, the water got really deep, so we dove down in that. When I dove in there, I just saw a mountain of shells from zebra mussels and mystery snails, both Chinese and banded mystery snails. And I thought, oh goodness, like this is a lot of biomass, a lot of dead shells, a lot of calcium that's been built up. I'm not sure what that's doing, but at that time it really disturbed me when I saw it, and I've mentioned it to people. And I'm not sure, and I don't know that anyone's answering that question. And maybe there's another person on the call who can comment, but I can't. Like, I think it's an excellent question because that amount of biomass of shell has got to be doing something. It's binding it up, or maybe it is releasing it back. I don't know.
Yeah, that is interesting.
Yeah.
Larry wants to know, can an infestation reduce calcium concentration? So I guess this kind of goes with the other question that Aaron asked.
I'm not sure. I don't know. But I think it's a really good question. And then someone else maybe on the call is better suited to answer it, but I can't. But I think it's an excellent question.
We do have time. So, I mean, if someone knows the answer or has a theory, feel free to unmute.
I'll share my thoughts real quick. I think that those lakes that have high calcium are continuously receiving more calcium-rich groundwater all the time, so I don't think the concentration in the lake would really change all that much.
Thanks,
That's true.
Paul.
And I even did say it's related to the bedrock. So you just get more and more and more and more and more calcium potentially.
Right.
But I wouldn't imagine it would change. It's just being bound up, but I don't know what that means.
Well, it's being bound in the shells, but then there's more being replaced into the lake constantly. So even though some gets taken out, more comes in instead.
Interesting. Thanks, Paul, again. We do have one question from John. He said, Big Round Lake is embarking on alum treatment this spring. Will this have an effect, positive or negative, on the suitability of zebra mussels?
Can you repeat that?
Yep. So Big Round Lake is doing an alum treatment this spring, and he is wondering, will that treatment have an effect, either positive or negative, on the suitability of zebra mussels?
I really don't know. Yeah, I can't answer that. I think that when they're talking about control, maybe somebody could better answer that question. I'm
Sure.
sorry.
Karen made a comment about the question and said that Big Round Lake is colored red on the map. I think Big Round is that in Polk County?
Yes.
Okay. So it is suitable on the map, but I'm not Maureen wasn't sure about the alum treatment. So maybe during the control session, someone might mention something about that possibly. Aaron did say to that question, alum is utilized to decrease phosphorus. So. Well, I don't see any more questions in the chat, and we're close to 10 o'clock. So maybe we could transition into having Greg, our next speaker, start putting your presentation up. And I just want to thank you, Maureen, for your presentation today and answering all those questions and having great discussion. That was awesome.
Yeah, thanks for having me.
Yep.
Okay. Can everybody hear me?
Yep, I can hear you.
All right. I am going to attempt to turn my video on here. Now everything changed. So maybe I won't. I was going to turn my video on just to introduce myself, but oh, I see it now. Okay. Can you see me now?
I can see you, Greg.
All right. So my name is Greg Matsky. I'm a fish biologist working with the state, Wisconsin DNR, and I work way over in the northeast part in Florence County, which Maureen kind of alluded to a little bit in her talk. And I'm just going to give a rundown on the impacts of zebra mussels on fish. And I'm going to turn my video off now so that it doesn't lag. Okay, so I was asked, a couple weeks ago to talk about the impacts or are there impacts on fish from zebra mussel populations, and it's really not something that we've looked at with a big microscope. We haven't spent a lot of time trying to figure out what's going on as far as zebra mussels and what their impact is on fish. And I'm one of the inland biologists that has had the pleasure of having zebra mussels for a longer period of time than most. I believe Matanga in 1999 was either the first inland population or the first inland population in northern Wisconsin, one of the two. And so we have data from our fish surveys from those, and I'm going to walk through some of those things. And so I guess just before I even start, generally what I had been telling people was that I didn't really see an impact, that I was not noticing any type of impact that zebra mussels would have on fish. And I'd get asked all the time, well, they're filtering stuff out of the water that larval fish would also eat. They may outcompete larval fish. And so you would think that you'd see some sort of impact, but I never really saw it. And so actually just yesterday, I decided that I was going to go through for this presentation and look at all the populations that I've had that have been established for a few years and look at what happened to all the different fish populations in there. And so that's kind of what I'm going to share with you today. And, it's a complete unbiased approach. I don't have a horse in this race, and it's data that I threw together yesterday. And it just shows what's happening. And we can all kind of make our own assumptions or try to figure out if we think zebra mussels are having impacts or not. So this is kind of my disclaimer slide. So first and foremost, this is not any type of a research study, meaning I wasn't funded to try to assess the impacts of zebra mussels on any given fish species. We didn't set up a proper scientific design, which in the past with research that I've done and research that I've gotten published, you establish that design ahead of time, you follow that design to make sure you're impartial. This is just simply observations, as I mentioned. It's the lakes that have gotten zebra mussels in the 2 counties that I manage and how the fisheries have changed since they've been there. And I'm in northeast Wisconsin, so not near the area where you guys are concerned with. You can see the red circle over on the right. Things may be different over here. Maureen showed that, some lakes are suitable, some lakes are not. So what's going on by me might not be the same over by you, but it is probably the closest data that we have to trying to understand what these fisheries are doing once zebra mussels are formed, their populations are formed. So all I'm going to look at is the comparable data. So we do fish surveys on all of our lakes on different rotations, and we have certain specific surveys that we do to assess a certain species. And we don't always look at every single species in the lake when we do a survey. So some of these lakes may not have pre and post data for every single species. We may only be looking at a few different species. And, with that, keep in mind that, there's a lot of population dynamics between the different fish species. Certain fish species go up in abundance, and that biomass has to come from somewhere else. When they go up, others may go down. So when we're not looking at the complete fishery, we're just looking at a slice. It could show something. It could show that things are improving or declining, but normally there are other fish species that are probably doing the opposite of the ones that we're looking at. And I am not a zebra mussel specialist at all. I can identify them. I don't know anything about their biology. I don't know the densities of zebra mussels in any of these lakes. I don't know whether these lakes were not suitable lakes and they never got developed or never became abundant, or if they're lakes that got super abundant. So if I was going to try to look at the impacts of zebra mussels on fish, I'd want to know the density or some sort of abundance measure of zebra mussels to compare that to the abundance of of a certain fish species. I don't have that. All I have are the dates where zebra mussels were found or first found, and I don't know anything else about that. And then just one thing that I wanted to put on there is, I am managing fish on my day-to-day, so I don't have a ton of time to devote to tons of other things. So I put together this presentation yesterday, and so my x-axis will be the time series, and it's not to scale. So just keep that in mind. You might see sharper declines or different angles of lines. Just remember that my x-axis is not to scale. And I think that's all the disclaimers here. And we'll start going through this. So again, the lake we've mentioned quite a few times, Lake Matanga. Zebra mussels were found in 1999. It's a fairly large lake, about 2,000 acres, oligotrophic. It was clear water system before zebra mussels. It's a very clear lake now. Largest lake in Forest County, has a very simple fish community. Perch, smallmouth, walleye are basically the three species that are in there. There are other species, but there's very minute populations. And then black bullheads came onto the scene in the early 2000s. And underneath that, I got a major biomanipulation, because one thing we got to remember is that I'm a fairly active fish manager. So there's lots of different, I guess, levers and buttons that I'm pushing as a manager on all these systems. And so there's other things at play here, many other things that can change a fish population other than just the presence of zebra mussels, one of which on Lake Matanga is this biomanipulation where we removed a large portion of the bullhead population starting in 2008 and so on. And so when I looked at Matanga and tried to find the comparable data, so we had to have data on a certain species from before 1999 and then after. Well, it's a walleye lake in the ceded territory, and we weren't very active in assessing anything but the walleye population prior to 1999. So the only species that we have are walleyes. And then on the bottom, you'll see this on all my slides about the lakes. It'll tell you what was not ideal about using this as a research candidate. So that major biomanipulation in 2008, where we removed a huge majority of the bullhead population, which changed the system into being a better walleye lake than it ever was. So when we look at walleye abundance, and in 1999, so right around here would have been when zebra mussels were established. Again, I have no idea how well established they were at the time, how long it took them to get established, how abundant they became, but this is what happened with the walleye population. So the walleye population did go down after that. We did do that biomanipulation, and I credit the increase in walleye abundance after that to that biomanipulation project. So you can't say, oh, zebra mussels showed up, walleyes got better. But one thing that I've always said is if zebra mussels were completely detrimental to a walleye population, say, Maureen talked about the substrates that they like. Walleye spawn on these rocky shoals. Say zebra mussels, cover all these rocky shoals, and that impact allows, eggs to not get enough oxygen or not be able to hatch. Then, maybe walleyes would stop reproducing, right? Well, obviously that didn't happen in Lake Matanga. Natural reproduction came back higher than it's ever been. We no longer have to stock this lake, which used to be stocked during much of its history, almost all of its history up till 2012. So the walleye population has increased since then. Can't credit it to zebra mussels by any means, but I would say that, if they were a detriment to walleyes, if they were like rainbow smelt, which is another invasive species which are known to collapse walleye populations very shortly after they arrive in a system, we wouldn't have been able to rehab this one. So I would say at a minimum, I think of this as, if zebra mussels were the detriment to walleyes, we probably wouldn't have had this success. And moving on to the next lake is Kai's Lake, which zebra mussels were found in 2010. It's a much smaller lake, about 200 acres, also oligotrophic seepage, very low productivity. And by that, I mean it doesn't support much biomass of fish to begin with. Used to be a good walleye, yellow perch, smallmouth system, but that was back into like the 80s. And this is one where rainbow smelt did hop in the system. It collapsed the walleye and perch system, and now it's kind of turned into a bluegill largemouth system. And so they were discovered in 2010. So I wanted to have comparable data. So I looked at the species that we had information on before in 2007, and then after in 2016, and then any other extra data points that we have on that population are more than welcome. They can help, show more of what's going on with that pattern. But we had to have surveys designed for that species, thorough assessments of that species pre and post, so 2007 and 2016, in order to compare them. And so the species that we have are walleye, both bass species, and then we got our summer spawning panfish, bluegill, pumpkin seed, and rock bass. And so here's what happened with the walleye population. And here's an example of when I was saying my x-axis is not to scale. Here we have a nearly 20-year gap, and here we have a 3-year gap. So this shows that it's a very sharp decline. It actually would be much more leveled out. But back in the 70s, very good walleye population. Rainbow smelt came in, and that population went away, and basically went from naturally reproducing population to a population that needed to be stocked, and stocked fish barely survive. From 2007, which was our pre-data point, to 2016, our post, you can see that walleye abundance has gone down. Again, it's a system where walleyes have been failing. Rainbow smelt had collapsed that system. Natural reproduction was gone. I don't know how much weight we can put into this from zebra mussels, but as far as this species go, at least from pre to post, walleye population went down. And again, this would not be an ideal research candidate, because we did do a major fish stick project where we put over 200 full trees in the lake, which tends to benefit those nesting species. And then we changed the largemouth bass regulation in 2014, which basically allowed more harvest of bass. We went to a no minimum length limit, trying to promote the harvest of bass in the system. And so when we look at the bass species from 2007 to 2016, largemouth abundance went down. It was up at a peak in 2012, which did lead me to changing the regulation in 2014, allowing you to keep any size largemouth. So in my mind, I think that angler harvest probably drove this down. But you don't really know. Maybe it was zebra mussels to some extent. Smallmouth bass have been going down throughout time, but from pre to post, they also went down. Whereas our summer spawning panfish, bluegills, and rock bass have increased in abundance from 2007 to 2016. Now we'll look at the spread eagle chain of lakes. It's kind of a unique water body. It is a 9-lake chain, but it only covers about 550 acres of water. These lakes tend to be around 50 to 100 acres in size. Almost every one of them gets to be over 50 feet deep. They're a collection of kettle lakes that are kettle seepage lakes that are made into a chain by a low head dam. So mainly a oligotrophic complex fish community. It's got every species that's there. And zebra mussels were established in 2013. So again, looking at our comparable fish surveys, I wanted a data point before, which was 2011, and a data point after, 5 years after, in 2018. And we'll include any other data we have on that species. And these are the species that we have that data for, and we can make our comparisons. Looking at the walleye population from 2011 before to 2018 after, you can see that it went down. There's always more than meets the eye. And again, you can see the not ideal down here because there was a change in regulations for almost every species in this system. But what I can tell you is that stocking was stopped for a while around this time period, which they become adults about 3 or 4 years later. So there's lots of reasons why abundance would have gone down over this period of time. There was no natural reproduction. and we stopped stocking for one of them. But if we are just looking at pre and post, the walleye population has declined since zebra mussels have been introduced, and northern pike population has also gone down. We look at the largemouth bass population. This is a very abundant population up in the 7 per acre range. Average abundance in my area is right around 3 per acre. So this has got a lot of largemouth in it. Also one of the reasons why there's fewer pike and walleye. From 2011 to 2018, the abundance did drop a little bit, but we also did in 2014 put a no minimum size limit on largemouth bass. So there was 4 years of being able to harvest any bass in the system, whereas prior to that they had to be over 14 inches. And so this is a fairly small negative decline, and I doubt that zebra mussels really had anything to do with it. Smallmouth bass over that time period increased in abundance. Looking at the panfish species, and so the pre-data 2011, post-data 2018, you can see that both blue or yellow perch and crappies increased in abundance over that time period. They used to be very high in abundance, and from 1979 to 2011 they dropped. They're fairly low abundance population, but they did increase since zebra mussels were there. Again, how much can we credit that to zebra mussel introduction? Because we also made a much more restrictive regulation on panfish on this chain of lakes. So lots of things moving, lots of moving parts in all of these lakes that are being actively managed. Same trend with bluegill, rock bass, and pumpkin seed. We got all 3 species going up in abundance since zebra mussels were put in place. But again, we changed the regulation on panfish. Switching to another lake, we got Lake Emily here. Lake Emily is 191 acres. It's a drainage lake, mesotrophic. It's basically a bluegill largemouth bass lake that also has, crappies, very few perch, pike population, and then we stock with walleyes. And the walleyes, it used to be a very good stocked water, meaning when we stock walleyes into a lake, we generally don't get good returns. About the best we can do is about 2 per acre in my area through a stock population. And Lake Emily was about a 2 per acre stocked walleye lake until probably around 2000 or 2005. It started coming down, and now the walleyes pretty much don't survive, or if they're surviving, they're being removed by anglers in a hurry, because the walleye abundance has only gone down through time out there. Again, this is only 5 years ago this was established. We have a data point 3 years after. I have no idea how much time it takes a population to become established if zebra mussels are even at a density where they would have been having any type of impact on the system by 2021. But just to make comparisons on all these lakes that have had zebra mussels for a few years, I grabbed a pre-data point in 2012 and a post in 2021. And these are all the species that we have comparable data for. So we assess their populations thoroughly with an appropriate survey. And when we look at that, and again, all of these have some non-ideal things about them. There was an artificial walleye reef installed in 2015 in an attempt to try to get walleyes to reproduce. That reef never worked to this point. So really it shouldn't have anything to do with it, but maybe maybe the presence of an extra half acre of rocky substrate changes something in the system. And then also just the fact that, zebra mussels have only been there for 3 years. And who knows, maybe when they found them, they'd already been there for a number of years. Or maybe they just found a villager. I don't know how all this works, and they're not established yet. Again, these things I don't know, but I can make comparisons in what happened to the fish population. So this is what happened in Lake Emily. Again, walleye would be this blue line, and you can see that their population through time has pretty much just gone down. And so it has gone down since zebra mussels were found. If we can say that changes from zebra mussels or not, I'm not sure. Northern pike population has gone up. over that time period since zebra mussels were established, with the pre-point being 2012 and the post being 2021. Largemouth bass population has increased tremendously. It's increased like threefold from 2012 to 2021. Again, when you have one species of, especially if you're looking at predatory fish, one species of predatory fish that increases in abundance that much, you're probably going to see other predators go down. So, these increases in pike and bass, it would be really hard for walleyes to also thrive while they are increasing. So the increase in these other competitors may be why walleye went down. Nothing is clear cut, and we can't pinpoint anything onto zebra mussels. But again, we're just looking at what these changes are in these fisheries. Looking at the panfish, here's our spring spawning panfish. 2012 is our pre-data point. You can see that black crappie have never really been abundant, but they have gone slightly down, I guess, since zebra mussels. And yellow perch used to be a much better yellow perch population. Pre to post, they've basically been not there, but it is a slight increase, I guess. And when we look at bluegills and rock bass, the bluegill population has gone down from pre to post, and the rock bass population has increased. I do have another water that got zebra mussels in 2020. It's Roberts Lake. So I just wanted to mention it. It's a 415-acre drainage lake. This one is a very productive system, holds a lot of fish biomass. Complex fishery, has almost every species present. And we have done a major biomanipulation out here where we've been removing largemouth bass and northern pike and juvenile central-arctic panfish in hopes to bring back the yellow perch and walleye populations that used to thrive in this lake. It's way too early for us to tell on any type of impact that could have been had out there. Plus, we would never really know what to attribute it to, because we did our biomanipulation project 1 year before zebra mussels were found. So to summarize, it's crystal clear the impact that zebra mussels have on these fish populations. I got in this chart, we got the 4 different lakes that I went over with the year where zebra mussels were found first found noted there. A green up arrow means that population became more abundant since zebra mussels were found. Red down arrow means they became less abundant. And anywhere where we have a black line, it was not evaluated. We did not do that survey. And so you look at some of these species and you think, oh, well, it looks like they're doing good things for bluegill, pumpkin seed, and rock bass, maybe even all panfish, yellow perch and black crappie. Game fish seem to be going down a little bit, but it's mixed results. One lake pike go up, one lake pike go down. And so, you tell me, what is the impact that zebra mussels have on our fisheries? And, I kind of phrased the question, is it crystal clear? And I would say that it's clear as mud, because here are all the things you got to remember about every one of these arrows. Lake Emily on the far right, again, they've only been there for 5 years. Is that enough time to even tell what the impact's going to be? A lot of these populations, like all the panfish in the spread eagle chain, I put a restrictive regulation on them in 2016, so of course their abundance is going to go up. A lot of these Kai's spread eagle chain, we have bass populations going down. Well, I liberalized that and made them a no minimum. As I said before, Kai's spread eagle chain in Lake Emily, they don't have any natural reproduction of walleyes. We basically stock fish in there. Should we even be worried about what's happening with the abundance of our stocked fish? Because walleyes have been declining everywhere, and we're not looking at natural reproduction. Matanga had that big increase in walleye. Well, that was a bullhead removal. There was a stocking gap that created this downtrend in the walleye population, and I guarantee the next time we sample it, the population will be up because we'll have more stocking events in there. So there's a lot of different things going on here that can manipulate and change fish populations. And don't forget that this was not a research project geared toward looking at what the impact zebra mussels have on our fisheries. But what I will say is that if they were detrimental to a certain species, like the example I gave before with walleye, let's say their establishment on these rocky shoals where walleyes spawn would stop any natural reproduction from occurring, we would see down arrows across the board. There's no way that we would have rehabilitated Matanga's walleye population, because we're, with other outside influences and environmental factors, our walleye populations are declining statewide. And so I would say my professional opinion, and a lot of these changes are very, very minor. And no matter what, when you're comparing two data points, you're going to get some change. Is it going to go up? Is it going to go down? And when other fish species go up, it takes away from the biomass of the other fish species and they go down. So there's a lot of things. I would venture to say that zebra mussels have probably had almost no impact on any of these populations. Really, the impacts and how they're moving are natural variations, competition between different species, and some species thriving and taking some biomass from others. And I would also say that, obviously regulations and different changes with habitat that we've done play a big role. So I think that the moral to my story would be, if I had to make a bet on how they're going to impact your fishery, I don't think they're going to have an impact. A lot of these fisheries are better now than they were prior to zebra mussels, as far as generally on a whole, in my professional opinion. But I don't think that zebra mussels are making them better. I just think that, the fisheries have changed for the good, and we've done some good with regulations and stocking protocols. So I'll leave that up to you guys to decide what impact they might have. I would say probably the most plausible impact that I could see, and maybe the only way that I would be nervous about my fishery if I had property or, loved fishing a certain lake very dearly and it got zebra mussels, my main worry would just be what water clarity can do to that certain species. And so, generally speaking, we have two groups of fish species that coexist very well in Wisconsin. You either have your yellow perch smallmouth walleye systems, or you have your bluegill, largemouth bass, northern pike systems. And yes, you may have more species in them, but those are the main and dominant species. And the yellow perch, smallmouth bass, walleye, they tend to thrive in a more turbid environment, a darker system. And then you have your bluegill, largemouth bass, northern pike systems, which tend to do better in highly vegetated lakes. So when water clarity increases, you generally get increases with bluegill, largemouth bass, and northern pike. So my main worry would just be, if you have a system that may not be super turbid, or it may not already be clear, it's kind of on the borderline. And if you establish a zebra mussel population, it may push it into that clear water system. You could get some flip-flop, and we might see some declines in walleye, perch, smallmouth populations, and more largemouth bass, bluegill, northern pike systems. But basically, that's all I got. I wish I had done some sort of huge research project and had a clean-cut idea of how your fisheries are going to change with the presence of zebra mussels, but I just don't. But the one thing that I would say is, I don't think you need to worry about your fisheries too much. I think that your fisheries have many other variables moving around. If there was an issue with competition between larval fish and zebra mussels filtering things out of the system, we would have seen it by now in these systems, and it just isn't. In my systems, at least, there just isn't an impact. We don't have any lack of survival of larval fish, and our fisheries are generally in pretty good shape. And with that, I don't know if we have time or not, but I'm happy to answer some questions. Again, I don't know anything about zebra mussels, but I can talk and try to answer questions about fish if anyone has any questions in that regard.
Thanks, Greg. We do have a couple minutes for some questions. I do have one in the chat already from Aaron. He was wondering, are there fish species that prey on zebra mussels?
There are. It is, so you have to look at our longer established systems, because generally they have to become abundant and then the fish need to change their behavior. Like on Lake Winnebago, there are certain species that have really started to thrive because they're eating zebra mussels. I know freshwater drum are doing, which are what people call sheephead. They're doing really well on Winnebago, and there's a couple other species that eat them enough that it does cause damage to them. When they're passing the shells and things like that, but they continue to eat them. So there are fish species that eat them. I think that when they become more established in our northern Wisconsin population, some of our native fish species will turn toward them and feed on them. But right now, I'm not seeing, fish behavior where I'm seeing fish turn to eating zebra mussels in any of the lakes while I'm out surveying fish.
Okay, thanks, Greg. We do have another question from Jeff. He's wondering, why is the walleye population declining in Wisconsin?
A lot of different factors. Climate change is real, and climate change has a negative impact. There are cool water species, so when water warms, it tends to lean toward, I mentioned those two different groups. We got the walleye group, which I call the perkid group, the yellow perch, walleye, smallmouth systems, and you have the bluegill, largemouth, northern pike systems. The warmer the water gets, the more it turns toward those largemouth, northern pike, bluegill systems. A lot of things that are really good for water quality may even be having an impact on our walleye populations, because as water gets cleaner and clearer, that tends to help vegetation. It tends to help bluegill, largemouth bass, northern pike more. Walleyes really thrive in the darker turbid populations. Now there are clear water systems where walleyes do well, but in general, the darker the water, the better suitable it is for walleyes, because it's called thermal optimal habitat. They're able to feed under those under that situation a lot better, and it keeps plants down and keeps those other competitors at bay. But there's a lot of things going against walleyes. Also things as simple as just look at your general angling behavior. If you're out fishing and you catch an 18-inch walleye and it's legal, you're probably going to keep it. You're out fishing, you catch an 18-inch bass and it's legal, my guess is you're throwing it back. You catch an 18-inch northern pike, it's legal, you're probably throwing it back. So anglers' preferences, there's a lot going against walleye. So yeah, we're seeing walleye populations, especially over the last 25 to 30 years, really taking a hit, and natural reproduction is going down. There's a lot of models out there that show there's going to be much less walleye populations, in the years to come. And so that's one of the reasons why I myself prioritize walleye management and try to do whatever I can to increase my number of good walleye waters and take special care of my populations that are in good shape.
Okay, good answer. Back to Jeff's question about the walleye Eric's question about what fish, or Aaron, sorry. Fish species prey on zebra mussels. We had two comments about round goby and snakeheads consuming zebra mussels, and common carp and shorthead red horse.
Okay.
So that's interesting. We do have time for one more question. Eric asks, isn't zooplankton necessary for fish fry to consume? In Mille Lacs, zebra mussels were measured at 1,000 per square foot in some areas, which would filter the entire 15-foot water column in a day.
Yeah, it is definitely necessary. Zooplankton is necessary. I don't know anything about Mille Lacs, and I don't know how prevalent the 15-foot water column is in that lake. What I can say is that I do have quite a few waters that have high littoral zones where you could get a situation where you have a really high abundance of zebra mussels, and it really could have some high filtering capabilities. And we're just not seeing any issues of any kind. There's really no fish species or any amount of recruitment or reproduction that has gone down in any of these lakes over that time. We're still seeing really solid natural recruitment. So I don't know what the mechanism is there. I mean, I get that would be a logical impact to fish. And I don't know what's going on. I know Mille Lacs has had some major walleye issues as of late. I don't know whether that has anything to do with zebra mussels or not. But yeah, we're not seeing it over in my waters.
Okay. Well, thanks, Greg. And we're at 10:35. I just want to thank you for your presentation and your time answering questions today.
No problem. I just got to figure out how to stop sharing now.
There you go. It should be at the bottom or top of, there you go.
Did I stop?
Yep, you're good.
All right.
So we are at our 10:35 mark and we have a 5-minute break. We'll be starting back up right at 10:40. So if you guys want to, feel free to get up and stretch and get some snacks or some food or snacks or beverages, feel free, but we will be starting back at 10:40.
Okay, thank you.
Yep. So as everyone starts making their way back, we're going to be starting here at 10:40. I have 10:39 on my clock right now. This next section, we're going to be hearing from 4 presenters and their experiences protecting Wisconsin's public boat landings and different ways the lakes groups have morphed the decontamination station. Lisa will be up first, and Lisa is the conservation coordinator with Washburn County Land and Water Conservation Division, and she's going to introduce us about the decontamination ordinance in the Northwest counties. So take it away, Lisa. You're muted.
Yep.
Okay, there you go.
Thanks, Emily.
Yep.
So good morning, everybody. I am going to turn my camera off here, but glad to be part of the forum today and discuss our ordinances, ordinance that we have up here in the northwest part of the state. So let's turn my camera off. All right, go ahead. So I'm just going to do a brief background, kind of what decontamination is. I think most of us already have a good idea, but in regards to our invasive species prevention, it is the process of removing invasive species or other materials that may contain or transmit invasive species. Decontamination stations are providing a method of decontamination that could potentially destroy or kill all forms of an invasive that might be present, whether or not we even know it's in a lake or river. Next. So the importance with decontamination, hand removal is effective. You know, if we can all do it correctly, getting little things off of our boats and equipment, the plant fragments, small animals that we can't see. But overall, decontamination is just another tool to help kill those invasives that we may not even be able to see, such as the spiny water flea or zebra mussel veligers, something that Maureen mentioned earlier this morning. Next. So here's a picture of what a decontamination station looks like. I'm hoping most of you have seen this at a boat landing. On the left there is kind of the materials that one can put together at a boat landing to have a station available. They can run different prices, $500 to $700, just depending on, maybe the lake groups or the individuals already have the lumber. That's usually the really expensive thing there, especially these days. But overall, these signs have been made in different places around Minnesota and Wisconsin, and I know lake associations have ordered them on their own. But overall, that's what a station looks like. And then we'll get into this in a minute, but if there is an ordinance, there's always a nice little space underneath there. Kind of, I have that arrow there. You could put your ordinance number there if people are asking, if this is a true law or what it is, to look it up more if they want more information. Next. So is decontamination required? I would basically say yes and no. It just depends what county you're in. So in 2017, our Zebra Mussel management team formed basically in Washburn and Burnett counties. And we started the discussion of getting an ordinance in effect. And there was a lot of different partners involved with that. And most of them were lake association folks. So they came to our county land and water departments, to our committees, and kind of, fostered this idea and the importance of it to help our spread of zebra mussels. So in 2018, Washburn and Burnett amended our no transport ordinance, which we already had, to basically include a decontamination station at a public or private boat landing if one is available for boaters to use. To date, that kind of caught on, and so we've added some extra counties into this ordinance, and those also include Bayfield, Barron, Polk, and Sawyer County. And what's really important is this is not a statewide law. This is only from a county's perspective. So the enforcement, which I'll get into, is thoroughly through our sheriff's departments, not the DNR. So as far as doing a decontamination, the ordinance requires boaters before entering and before leaving a water body to spray the solution around the perimeter of the boat, trailer, and anything else to make sure that the entire surface is sprayed off. That fine mist is super quick at drying off, and it's not going to just drip all over and run into the lake. And it's also advised to use the brush and potentially the weed grabber, if there's one there too, to get off any weeds that are hanging from the boat. And keeping in mind that that's already law, state law, to remove all of our plants and other debris when needed. And then it's really important, if you can, to spray those live wells as well. So I talked about the solution, and the solution is mixing 2 tablespoons of bleach per gallon of water. And who's going to be maintaining these stations? So it comes down to potentially a lake association member, Clean Boats, Clean Waters inspector, or just any other volunteer that is willing to change the solution as needed. And keeping the sprayer in a plastic bucket, like a 5-gallon bucket, will keep that solution longer, more viable. It's not going to break down as easy just sitting out in the sun. And there was a study done actually by Bob Baker, which we're going to hear from next, but he did a really big study on the breakdown of the solution in the sun. So next. So this is a big question. We get this a lot from boaters, especially the big bass fishermen, tournament fishermen. Is this solution gonna harm my boat? And there has not been any cases done, or I'm sorry, no cases known that this has ruined the vinyl or the siding, or I'm sorry, the side of the boat, the gel coating. And we did reach out to Ranger boats and Tuffy boats, and they pretty much vouch for that's not gonna have any effect on the boat.
Lisa, this is your 3-minute warning.
Okay, thanks. So this is kind of the big one. People ask about enforcement, and if the county does have the ordinance in effect, it's up to the sheriff's department again to help us out with enforcement action. So it's reported to them, and then usually a recreation officer will follow up with a boater, and that also goes on to file. And fines are going to vary by county. And usually at this point, we haven't had a whole lot of fines going on. It's been a lot of education with our boaters. And it's also important that if a county doesn't have an ordinance, this is just voluntary. So, and keep in mind also that the state wardens don't have the authority to enforce this law. Next. So this is a list of the counties that have decontamination stations, just the 3, Washburn, Burnett, and Polk. I won't go too much into that, just to keep moving on. Next. Here's a frequently asked question sheet that was formed. So if you're interested in other questions that we're getting from boaters, this is kind of a good handout to have. And I can include that in an email once the recording goes out. Next. And also, if you're interested in learning more about the decontamination videos and how to work with our boaters, whether or not they want to comply or they just don't understand it, this is a good website to check out on our county website. Just search Washburn County Land and Water, aquatic invasive species, and then decontamination. Next. And here's our contacts for different counties with the ordinances. Any questions?
Lisa, we might not have time for questions, but we do have one in the chat. So maybe if you wanted to pop in on the chat and answer Greg's question, it's about the bleach solution.
Okay, great. Thank you.
Thank you, Lisa. Up next, we have Bob Baker. Bob Baker serves on the Lipsey Lake Association in Burnett County, and he is the secretary and treasurer of the Burnett County Lakes and Rivers Association. Bob is going to be discussing Lipsey Lake's innovative pressure wash station that's installed at the public boat launch in place of the bleach solution that Lisa was just talking about. So go ahead, Bob.
And Bob, you are muted right now.
Okay. Yeah, if you want to unmute Bob.
I thought I had. Okay.
I can hear you.
Mic on now? Okay.
Yep.
All right. Well, we'll try again. Thank you for the introduction, Emily. I thought that I'd give you a background on Lipsett Lake. We're located in very easternmost Burnett County, north of Highway 70, and only a little over 2 miles south of Big McKenzie Lake, where, of course, zebra mussels were found in the fall of 2016. We're also one of the lakes that has a high calcium content. Therefore, we're quite suitable for zebra mussel introduction. Okay, next slide, please. So because of that, we were sort of hit the panic button once the zebra mussel discovery had been announced. And so in the spring of 2017, 2017, we took advantage of the decontamination law ordinance in Burnett County and put in a decontamination station using the pump sprayers that have been discussed by Lisa and others this morning. One of the things we were concerned about was, of course, these things sit out in the hot sun all day long. And next slide. Next slide. There we go. So I did a study, and I'll just quickly summarize this. I published in Lake Tides in the spring of 2019 with co-author of Pamela Tosner from the Burnett County, or excuse me, from the DNR office in Spooner, Wisconsin. And basically what we found was that if you shield your pump sprayer with about roughly 1% to 0.5% bleach solution, if you shield it in a plastic bucket, let's go to the next slide. You can see in these graphs on the right, the numbers are too small to see, but the bleach solution will maintain its integrity of about 500 parts per million for about 6 days if it's shielded in a bucket. If it's just out in the direct sunlight, it breaks down quickly in about 1 day. It's no longer going to kill zebra mussel Bellingers. And so, of course, that's why we put that in Lake Tides with the idea of letting people know around the state who have these kind of decontamination stations that the best way to go is to shield your bucket, your pump sprayer in a bucket. Next slide, please. When COVID-19 hit, we were really worried that people wouldn't want to use the pump sprayers because they don't know who's been using it ahead of them. And so one of the members of our Lake Association, Aaron Temple, who's actually asked several questions and earlier speakers today, came up with an ingenious idea of let's put a hand sanitizer right at the decon station so that people can make use of that. And sure enough, we put that in summer of 2020, and immediately people started using that, and it didn't affect the pump sprayer usage, fortunately. We probably had to fill it twice a week that first summer. Now that the COVID pandemic has subsided quite a bit, last summer maybe only filled it twice. So that's worked out to our advantage. Next slide, please. But, the pump sprayer being a pump sprayer, you've got to refill these things a couple of times a week, a couple of times a day in some cases during high usage periods. And they're only as good as the sprayer. If somebody, just cursorily sprays their boat and trailer because they got to do it because somebody told them they needed to and they don't really care about it, it doesn't do much good. Next slide, please. So, and another problem too was that some people were just refusing to do it. This is one of our Clean Boats, Clean Water data sheets from summer of 2018. And second summer we had the bleach station up, and you can see the B's on the very right-hand side. Those are indications that they had bleached. And so about 50% of the people were refusing to do it. It just wasn't being effective. Next slide, please. So at a McKinsey Lake Association or Lake Area Zebra Mussel Management Team meeting in the fall of 2000, Kathy Erickson from Stone Lake made a presentation about what I thought was a really innovative approach to getting boats to decontaminate and not use pump sprayers. They chose to put in a pressure washing system. They used a battery operated pressure washer, which was, I'm going to call it a low pressure washer, only about 70 PSI max. And they had a water reservoir with 16 gallons. So it's a great alternative to the old pump sprayer idea, but it had some issues that with the battery needing to be recharged and then the reservoir being needed to be refilled. And of course, the pump sprayer not being terribly forceful. So our Lake Association made a decision based on this that, boy, this is a great idea. Let's see if we can embellish it and do something a little bit better and make a system a little more robust. So we decided to put in a well so we'd have infinite water supply, bring electricity down, and put in a pressure washer that has a little more oomph to it, a little more robust pressure washer. Next slide. So that involved, number one, getting our township to say it's okay to use their land to put in a permanent station like this with a well and electricity and pressure washer. They said, fine, if you want to do anything to, this is the township of Rusk, but if you want to protect your lake, go ahead and use our property and feel free to do that. So the first step, of course, was to do some clearing so that we could get, next slide. Next slide, please. There we go. And a drill rig in to put the well in. So we had Beecroft well drilling come in. They put in a 70-foot well. The water tested great for drinking, although that's not what it's used for. It's for primarily, entirely. I don't think anybody's ever taken a sip out of this, but it's for decontaminating boats. Next slide, please. And what you can see here too is that, by the way, I should have pointed out at the very beginning of this decision to put in this kind of a system. I was naive. I thought, well, by gosh, we'll just get this thing done and have it running by the 4th of July. Well, you can obviously see this is the end of the summer of 2021, and we still didn't have the thing going because of all the various steps, getting a well drilled. On the very left-hand side of this photo, you can see the electrical meter. We had to have power brought down the hill from the nearest power pole by Barron Electric. So that took time to get them to do that. You can see on the ground behind the fellow with the gray shirt on, there was a concrete slab we had to have poured next to the well. That was where the pressure washer will be bolted, and then this gray box that we're putting in place. We had that fabricated to protect the pressure washer from vandalism and theft. Next slide. One of the other things we did, which I didn't think was necessary, but one of the people from our lake, a fellow named Chuck Edwards, said, yeah, boy, you know, we probably ought to put bollards in. These are the kind of posts you see at parking lots to keep cars from jumping curbs and banging into storefronts. And so we did. We put in 4 bollards. They were 7 feet long, 6 inches in diameter, made of steel. They weighed a ton. We anchored them in with concrete and then filled them with concrete, and they were all painted yellow. So you can see several steps in the process of doing this. And in the lower right-hand corner is one. It took it last spring, just before we opened up for the season, and you can see a big scratch in the bottom of that. That bollard actually protected our metal box and pressure washer during this first winter. A snowmobile trailer backed into it and bashed up their snowmobile trailer because there was red plastic all over the place. So it already paid for itself before we'd even used the pressure washing system yet. Next slide. The pressure washer we chose to use was a Comet. We bought it from Northern Tool and Hydraulics, Northern Tool and Equipment. All the costs of all these items we'll get to in the next slide. But this is it's a 1300 PSI unit. It has an automatic shut off so that if nobody's using it, it'll just turn itself off. It won't just burn itself out. It had a 70-foot hose, which we thought was appropriate because it allows people to get on all sides of a large trailer with a pontoon on it and get under the boat and not be short cabled, not have enough cable to do what they or hose to do what they wanted to do. The hose reel, initially we just basically unspooled it from the hose reel and had it hanging out a hole on the right-hand side of that gray box. The idea that people could wind it around a couple of hooks there, much like you would do an air hose at a gas station. That really didn't work. That was something we had to change because it would kink and people get their hands all dirty trying to do it by hand. So we by maybe the end of June we took the hose reel off of the pressure washer that was inside the box and moved it to the outside and bolted it to the box so that people could just use the crank then to crank it in and out, and that worked much better. Next slide, please. Well, one of the, we have the signage around reminding people of the ordinance, saying that they have to, because there's a decontamination station here, you've got to decontaminate upon entering and leaving the lake. And I'm pleased to say that when we had Clean Boat, Clean Water workers, and we've been doing this for about 20 years, the Clean Boat, Clean Water, that's one of the reasons we wanted to do the initial pump sprayer, because we knew that it's not uncommon to have a boater come into our lake after having already been fishing on Big McKenzie or Middle McKenzie. So we know we're vulnerable to having zebra mussels introduced into the lake. But I'm pleased to say that our Clean Boat, Clean Water data takers reported that not a single person refused to use the pressure washing system this summer. They used it. In fact, you'd have to stop them sometimes because they started to clean their trailers, not only their trailers, but their trucks, shine them up, get the bugs off the windshield and so forth. The other thing that we had problems with, though, next slide, please, was that it was not uncommon to see an early riser, somebody who was in the lake already fishing when one of our Clean Boat, Clean Water inspectors came on, and we have them on 5 days a week this past summer. But it would be not uncommon to see they hadn't decontaminated, and that was clear because there wasn't a big wet spot next to the pressure washing station. And so we started putting notes on windshields, reminding people of the ordinance that they needed to decontaminate coming in and leaving the lake, and then asking them to please use the pressure washer that we have available for them, and thanking them on behalf of the Lake Association. As the summer went on, we put fewer and fewer of these on windshields. So people were starting to get, even the big brother's not watching, I'm supposed to be doing this, and they started decontaminating. And so that hopefully this summer we won't have to put very many of these on board on windshields. Next slide, please. Well, I said I'd get to the cost of this thing, and you can see the bottom line on this. It was not inexpensive. This was not something that you just, it was a tough decision to make, but let's go through the cost for you. Well drilling costs were the most expensive, about $6,500. The cost to bring power down to the well and get that all hooked up was about $1,565. The concrete slab, a little over $800. The metal box, we had that fabricated in Spooner at North 40 Steel, $830. The Northern Tool and Equipment, Comet Electric, cold water stationary, 1,300 PSI pressure washer with a 70-foot hose, that was $685. Steel bollards, $1,338. Liability insurance, that was something else we decided we really needed to do, just in case somebody gets injured using it. They spray their child in the face by accident and they try to sue the association. We needed coverage for that. So we have liability insurance, which is about $1,342 a year. And then some miscellaneous expenses of about $186. So call it about $200. So the total $13,321 at this point. To quote Mark Milley, the chairman of the Joint Chiefs of Staff, he said, "The pain of preparation is much less than the pain of regret." Our Lake Association knew this was a big expense, but we thought, boy, it makes sense to spend this money right now and do everything we can to protect our lake from the introduction of zebra mussels than to not do anything and wish we had taken a step like this and put some money up front to try to protect the lake and keep zebra mussels out. There's no guarantee we're ever going to keep them out, but boy, we're doing everything we can to try to do that. Next slide, please. Well, what I've got here is just a short video. It's actually several minutes long, and let's go ahead and run this. We'll watch about a minute of it. It won't take very much time here, but I want you to see the pressure washer. I don't think you can hear it, but boy, I want you to see that this thing really does have 130 or 1,300 PSI. It'll blast everything right off the boat, from sponges that may be on the side of a boat that's been anchored by a dock for a long period of time, to the course of zebra mussel belly. Now there's a little bit of sound coming up, so that's good. I'll be quiet for a minute. Okay, I think that the video can stop now, and I'd be happy to entertain any questions that come in through the chat or orally.
All right, thank you, Bob. Yeah, we did have a question come in from Brad. He said, could you have used a shallow point well versus a drilled well?
We perhaps could have, but we decided that, we could have. when you say shallow point, if you're talking about a sand point that we drove down ourselves, we just, some of the cabins on our lake have that. In fact, my original cabin had a sand point that we put in ourselves, but we decided we wanted a drilled well, and the bid we got, the cheapest by $3,000, was that $6,500 bid. And they wanted to do what they called a medium depth well. 70 feet was about as shallow as they were willing to go. And so we went that way.
Okay. I think, Carrie, you had your hand raised. Did you want to ask a question? Yeah,
I just typed it. My question is this using a bleach solution or just cold water?
We're just using cold water, no bleach solution. You can see the force on that thing. It'll just blast everything right off the side of a trailer and a boat. So we're not worried about, so no bleach solution necessary. I think the one that Stone Lake, I believe they're still using bleach solution in their reservoir, but we're not doing that here. Just plain cold water under a great deal of pressure.
All right,
okay,
thanks,
thank you
Bob.
very much.
Karen asked, is this system using hot water?
No, it's a cold water system, and so that makes it a little bit less expensive and one less thing to worry about trying to generate hot water. So no, it's just a cold water system using groundwater temperature, which is about 45-degree temperature water.
Okay. This one, a two-part question. You might have answered the first part already. Is any bleach combined with the water or just plain water under pressure? And is this sufficient to kill zebra mussels?
The fact that you're blasting them off should kill them off. They're going to land on the parking lot and not get into the lake. So, and as long as people are careful with it, I mean, the problem with the bleach solution was that with the pump sprayers is that people were haphazard about it and not being very careful about thoroughly spraying their boats and trailers. We're seeing much better thoroughness and people being more conscientious when they're using the pressure washer.
Okay, thanks, Bob. We did get a comment from Amanda Smith. She's from the DNR. She said, thanks so much for your leadership, Bob. Really impressive. Amy Jers asked, time frame for build and implementation of the station.
Yeah, that's kind of snuck that in without making it very clear. That took us really a full season. We approved this at our spring meeting, which was Memorial Day weekend in 2021. And we finally, about the time the leaves were falling from the tree in October, had the thing where it could have run, but by then we were having frost in the evenings, and so we just never really got it going during the 2021 season. We opened it up just before Memorial Day, the fishing opener at the beginning of May last spring. So 2022 and around May 1, we got it going, and it ran the whole season.
Okay, thanks, Bob. We do have one more question from Lisa, but we are out of time. So if you could just pop in the chat and answer Lisa's question about fundraising or donation for the station, and we'll move on to our next speaker. Thanks again, Bob.
Yep.
Our next speaker is Carrie Olson. Carrie is representing the Bone Lake Management District in Polk County, and he will be presenting on the CD3 station installed at the public boat launch. So go ahead, Carrie.
Okay, thank you, everyone. So I am the chairman of the Bone Lake Management District. So I'm going to go through quickly how we decided and our installation process and what we are seeing on usage. So next slide. So for our process, first thing we did is we wanted to form a team that would shepherd the project all the way through. We actually tried to get a number of fishermen on the project. We only got one person that was willing to commit to the project. I don't know, I think they're a strong band of people that didn't want to get involved. How to choose the unit, there's multiple CD3s, there's also the bleach flaring. We broadcasted information via social media. Via our Facebook page, via email blast, to make sure that the lake owners knew what we were doing at every step and how we were progressing. Our biggest thing was researching our site. We decided our largest site was going to be the first one, which is, if you've been on Bone Lake, the North Landing. So we had to decide exactly where to put it. Going through the grant process, which is some work, but it's not too onerous. Customizing our unit. You have a lot of different variations of type of graphics you can put on there. Installation and what we went through there, and then final the reporting. Next slide. So why we chose the CD3? Like a lot of people, we felt that we'd get hesitancy from boaters using bleach. I'm glad to hear that Bob and that had great success. Hopefully we could go forward with that at our South Landing. We saw refills as being an issue. We have a lot of boat landings on Bone Lake, especially the tournaments. We have over 3,000 landings a year. To be having to refill it all the time, and as I said earlier, hesitant boaters. We liked it because it's a self-contained, self-directed. Everything tells you what to do. When we started it up, we did not have power. And so we just have the people use it as they could, and they just follow the directions. Aesthetically pleasing, it looks very nice. It has a very good reporting system and warning system. So it will tell you if the sump is full of water, if one of the brushes or something is not broken, if the compressor's out. The big thing for us, why not? For other people, it's cost. I mean, the unit is expensive, but we thought it was well worth it because of the volume that we had to maintain boaters. And there's an annual fee, data fee, but it's not that onerous. So next slide. Finding the site, how many launches we have to handle per season and per day. The fishing tournaments are a major one. The muskie tournament, we have over 75 boats coming back and forth between Deer Lake, who does have zebra mussels, and major holidays. Like I said, we have over 3,000 launches. On a busy weekend, we can have 200 boats or more coming in and out. Space for vehicles and trailers. You got to have room for turning around, proximity to the ramp. Doesn't block traffic. If you know the North Landing, we have a real traffic problem there, a narrow road and not a lot of parking. We did use our experts. I mean, we had a long time Clean Boat, Clean Water group who spends every weekend and during the week there. I'll go through why and what we found out from that. We had to decide solar versus electric, power versus sunshine. The North Landing has a lot of trees, and so that's why we chose power. Also, the ability to constantly have the unit up and running, where solar, you can only do so much before you're going to burn out the power in your batteries, and it have to be recharged overnight. Continuous or limited capacity. Next slide. So this is the North Landing. Picture on the left, you can see the geo information showing, what we were planning to do. You can see the CDC red box there, way off to one side. You're going to have to make a big loop and pull in. Through our discussions and while we spent many hours talking about where to put it, our leader of the Clean Boat, Clean Water group came and said, I've been watching this for years, and there is plenty of room to go on both sides of a unit if we could do that. And so we ended up doing lots of measurements, watching, and finally decided that we could make it two-sided. Now, the equipment is on one side, but the cables are long enough and the hoses are all long enough to reach the other side. Sorry for that. I had a dog that had to go outside to the bathroom. So if you could go back to the other slide there. So you can see that we have both sides, the back side and the front side. Next. So our biggest issue is where we were getting the power from. We had a pavilion that has power, so we were lucky. It's about 200 feet from where the unit was placed. We used the larger unit that runs on 240 volts, so we had to figure that out. Our biggest issue was we know we had previous lines, power lines going to the light pole down there, but also we have a camera station and there was Ethernet lines. So we had to work with Lakeland, who are very, very good, and the guy Eric Lindbergh, who has the cameras. And we had to consider making sure that we didn't hit those lines. So we took a lot of time, and we actually found old photos of when they buried the Ethernet line. So that helped, but we still had to trace it, and that took some time. So in the future, if you ever do this, make sure you take pictures and save them in a file that everybody can access. Next. Getting our grant, it's a longer process than the normal grant. You have to do a pre-application that starts in September to get done. You have a pre-application meeting with the DNR. The grant application then goes in on November 15th, and then the grant approval, which obviously we received, is a 4-year grant with depreciated capital equipment. So the DNR takes the depreciation, and so you're going to get a grant for 4 years, but all your costs are going to be in the first year. Obviously, because it's for us, that property at the North Landing is the Bone Lake Township, so we had to get our legal process to use that. We had to decide with them how we wanted to insure it and have the liability insurance. We actually ended up donating the unit to the township, and they pay the insurance because their bill for the insurance is a structure, since it was bolted down, with $60 a year, where ours was going to be over $1,200. So we pay the maintenance and replacement cost. We also have to sign a professional service agreement with CDs3 by rules with the DNR to get the grant, and that was easily done. Next slide. So ordering our unit, we decided which unit to purchase. As I said, you can get something from them as far as just a tool holder to smaller units that don't have a vacuum or a compressor to pull off the villagers and then clean out sumps and that, all the way up to the full size unit, which is what you're seeing there. We calculated a 12-week lead time, and we figured we'd start getting that stuff on ordered. We ordered a concrete base, which is a lot easier and faster and probably cheaper than trying to create your own. Deciding on our graphics, we had a lot of choices that you could use as far as the graphics on the top, and then deciding on your tagline. We worked with them using what they have in stock from all the other ones, and you can see on the bottom, and it's just protect Bone Lake, clean your boat. Very catchy, and you can see that there's different aquatic species that are on there: zebra mussels, stony wort, and Eurasian milfoil. We decide to order winter cover. You got to have this thing covered just for safety and keeping dust and dirt and people out. So Next. Finding subcontractors. This was the biggest issue that we had out of the whole process. I thought it would be relatively quick. Contacted a number of companies locally, found that it was very hard to find people because they were very busy and very few of them. There's not a lot of people that are willing to do this project because it's relatively small. And so we had to find electrical site prep, which is really level and grading. And as Bob said, they decided to put in bollards. Yes, it's a must. We're protecting it on 4 sides. And already one of them has been hit so hard that it's actually loosened the cement that's going down 4 feet. So somebody really cracked their trailer on it. But we have no issues with the unit so far, or even getting close to it. Next. Startup, biggest thing was training our clean boats, clean water. By the time we got the first equipment, it was in end of June. By the time we got it started, it was mid-August, so it does take a time to get all these vendors, contractors lined up. But we cleaned the clean boat, clean water group. It's very simple because it's a self-directed unit. They could help show people, what buttons to push and to help them out. Create signage, which we are still in the process of doing, because by the time we got the unit running and got it powered up, it was late August. So we just decided we'll work on the signage over the winter, and we're doing that. We've got obviously signage for the ordinance, the flow of vehicles, stop points where to pull up your trailer and boat and vehicle to stop, handouts that we're going to be handing out, similar to what others have shown. We publicized on the website and via Facebook that the unit was available. In fact, we asked people they could free to use it before it was powered. They were people who were up there using the brushes, and that already. And then we prepared the clean water group for hand holding the boaters, and that's going to be the big start this next spring. Next. Okay, so there is a reporting system in the unit, and you can use that data to make all kinds of reports. So here you can see that tells you each one of the uses, the air uses, which is used to blow off the boat and trailer to get rid of weeds and villagers and that, brush uses to scrub it down, light uses, plug wrench, reach grabber tools, and vacuum uses. So you can see how many actual different components were used. And this is one where, this really helps show up. If you look at the brushes, it only had 10 uses for 3 months. So I called up CD3 and they said, well, yeah, it's not the retractor is not pulling it back to reset the sensor. So we just had to tighten up the spring and get that back in operation. The sessions, you can see there that how many sessions we have based on the total, 246. And what we found is with this, we actually calculated, so we had 246 uses. That's, going in and going out. And we know the total number of landings. And we calculated that without being told or without, enforcing anything, we had a 19.3% usage of people using it, which we thought was pretty good for the clean water group, not even talking to them about the unit unless people ask, because we didn't have any enforcement, because we didn't have signs up. So next slide. This is just a graphical bar chart showing you the different usages. A lot of air, everybody was using the air. And in fact, there's even people using the air to blow up inner tubes and stuff. But the vacuum uses and light every time at night. You can turn the light on. So next. So questions. Anybody have any questions?
Thanks, Carrie, for that presentation. We do have one question in the chat so far from Lisa, and she wanted to know what grant did you apply for this CD3?
It is it's not a clean boat, clean water, but it's lake usage invasive species. I'll post it to you.
Okay.
The grant, actual number and stuff. So
we do have 4 minutes for questions. So if anybody has any other questions, feel free to plug them into the chat. Dale asks, how much time does a user take with the cleaning station? Did it create a traffic jam at all?
So that was one of our big concerns. We, as a group, with a number of us, went and watched the muskie tournament, and so you have people that are really good at taking their boats in and out. And after watching that, we saw on average it was about 5 to 8 minutes for somebody to get their boat connected up and pulled out, who do it all the time. And the time it takes to use the equipment is about the same. It's somewhere between 8 and 10 minutes. And we saw that basically corresponds with, we only have a boat launch that can launch one boat at a time, so you're going to have a queue no matter what. So it really wasn't detrimental to backing up traffic, because it was going to take that much time to either drop your boat or pull it out.
Okay. Next question is from Ryan. How much did the unit cost to purchase and get operational?
Okay. I went through that this morning. So the unit itself was, and this is their, the solar powered unit is more expensive than the electrical power, just because of batteries and stuff. The cost for us was $34,500, fully with electrical site, shipping, and that it's $41,000 that Bone Lake put in. And we are intending to get another unit, same unit, for the south landing. Unfortunately, we missed the start date for the pre-application, so we're waiting to next year. But
okay, thanks, Carrie. We do have one more question in the chat, and just time for one more. Amy asks, was the water brought over from a shelter with electric?
This unit uses no water.
Okay.
It's got a compressor to blow off high pressure air. It's got a vacuum, so it can suck weeds up. It can suck the bait boxes out of all that water. So it is a dry system. It has been tested and approved to be just as efficient as using high pressure water and bleach.
Okay, thanks, Carrie, for your presentation. We are out of time. We don't have any questions in the chat, but there might be some coming up maybe in a little bit. So if you just wanted to pop in the chat to capture those. Our next presenter is Colton Sorensen. Sorry. He works at Polk County Land and Water Resources Department as their water quality specialist. And Colton will be presenting on the Indian Head Pro Muskie Tournament decontamination outreach efforts and how to reach fishing tournament boaters about the importance of decontaminating at the landings. So take it away, Colton.
Thanks, Emily, for the great introduction. So the Indian Head Pro Muskie Tournament is hosted by the Balsam Lake Rod and Gun Club. It is an annual tournament, and in 2022, it was the 48th annual. The tournament is between Deer Lake and Bone Lake, which Bone Lake is the lake that Carrie was just speaking about. This is a 2-day tournament, so there's 74 boats or 148 anglers in the tournament. And there's 37 boats on deer and 37 boats on bone. And how it works is they draw for their first lake and fish the opposite lake the second day. So the reason why this is concerning is because Deer Lake has a verified population of zebra mussels that was found in 2016, and Bone Lake does not have zebra mussels. An interesting aspect of this tournament is they have a mandatory angler meeting the night before. And at this angler meeting, they have angler registration, go through tournament rules, and they draw for lakes. It is a random draw on how they do it. And you can see on the left here, here's actually the board with all the teams and the members of the teams. And then kind of farther on the right side, they actually post the length of fish they caught in the tournament. So in 2021, tournament organizers reached out to the Land and Water Resources Department regarding steps to prevent the spread of zebra mussels, and mainly what they could do at this tournament to really help prevent that spread. And in 2021, I attended the angler meeting and gave a brief presentation. And in that presentation, I discussed Zebra Mussel 101, so the identification, the life cycle, things like that, AIS prevention and steps and decontamination, while also providing AIS handouts and specimens. So I actually kind of set up a little booth and had a bunch of different specimens and some watch cards and things like that, where anglers were able to come talk to me, ask questions, regarding zebra mussels, and really, make a positive interaction at this tournament. Now, moving forward into 2022, in preparation for the tournament, the Balsam Lake Rod and Gun Club actually purchased 6 pump sprayers with the bleach, or to put bleach solution in to leave at the Deer Lake landing during the tournament. So at the angler meeting again, I presented, gave a Zebra Mussel 101. I went through the steps of decontamination. So actually, teaching them how to use the pump sprayer and properly decontaminate, as well as the steps when using the CD3 station at Bone. As I also discussed the decontamination ordinance this was the first summer that was enacted. So the sprayers at Deer Lake, staff made sure that, tournament staff that is, made sure that the bleach solution was full at all times, so 2 tablespoons per gallon during both days of the event. The reason the gun club went with 6 sprayers is they just wanted to make sure there was no holdups. Everything went very smooth. So they just decided with a low cost sprayer, they'd just buy multiple for this event. After speaking with tournament organizers, generally anglers did the decontamination, but staff were available if anglers asked them to decontaminate for them. About 75% of the boats use the decontamination station, which honestly, for the first year of this and spraying the bleach concentration, I'd say that is extremely good numbers to have. Now, moving forward, we have been asked to keep attending the angler meeting, providing zebra mussel awareness, invasive species updates, kind of that, again, invasive species 101, obviously talking about zebra mussels, but there's a lot of other things to be concerned about, like Eurasian water milfoil, as well as, discussing decontamination. Also, part of this tournament is keeping the sprayers at Deer Lake Landing during the tournament to ensure that, these people are decontaminating their boats, specifically in this tournament when they know they're going to Bone Lake the next day. The goal is to have 100% of decontamination at both lakes using the sprayers at Deer and using Bone Lake CD3 station. That's the overall goal. Moving forward. And the other goal is to just change angler behavior to include decontamination before and after leaving a lake every time. And I'm just going to leave you with this quote here from the chairman of the tournament, that the Balsam Lake Rod and Gun Club strongly encourages the fishermen to clean their boats and live wells after leaving and before putting into any of the area lakes. And with that, I will take questions.
All right, thanks, Colton. We don't have any questions in the chat yet, but we do have 5 minutes until our next presentation. So, oh, now we just got one. So Aaron asks, have they thought about not doing an intentional cross-contamination event, knowing that one lake has zebra mussels and one doesn't?
Yeah, so this came up many years, and that I think was what sparked kind of the gun club to reach out to us to provide this education. Is, I had mentioned that this is the 48th annual tournament, and so they've been doing this tournament a long time between these two lakes, and I think it's just kind of tradition is one of the reasons they are still keeping it this way. And I don't want to speak for the gun club and their stance on this, but it has been discussed many times, and they've talked about potentially if they were to move it to Wapagasset Lake, which is just kind of right down the road as well. However, Wapagasset in 2022 just got infested with zebra mussels as well, so that kind of rules that lake out, unfortunately. But it definitely has been considered, but the tournament has decided to keep it as is.
Okay, thanks, Colton. Diane asks if you could share with us the 2023 tournament dates if you have them. The DLIA could possibly assist the landing and add more sprayers.
I do not have the date of the thing currently, but I can tell you when last year's was, and it's on the same weekend every year. I will put that in the chat. I'll try to find it in the chat and send when it was last year. If you would like to email me, I can definitely get you in contact with tournament officials to help with the process. That'd be very useful, I think.
Okay, thanks, Colton. Vicky says maybe they should make the decontamination a requirement to participate. Just a statement there.
Yeah, and definitely considered, but it is an ordinance as well, and so it should be followed fully. But the gun club, they want to make this enjoyable experience, with everything, and trying to just strongly encourage everyone to do it instead of making it mandatory for the first year. It may, they may shift to that in the future. Like I said, I don't want to speak for them on this topic, but they are considering all these options.
All right. Amanda Smith asks, is this a tournament that required a permit by the DNR fish biologist?
I don't know for sure, but I'm guessing so. I know they actually work with Aaron Cole, he was the fisheries biologist for this county. It's now Kyle Broadway. But they have actually worked together on the tournament and had scanners present the day of, because many of these fish actually do have a pit tag in them. So they've actually partnered with the DNR on that.
Okay, we do have a lot of likes on this question. We only do have 1 minute left, Colton, but Dale asks, both lakes are in Polk County. That requires use of cleaning stations if present. Can you comment on that?
Yeah, so obviously it is required, but there wasn't, getting back to Lisa's presentation, it's enforced by the sheriff, so there would actually have to be a sheriff sitting there enforcing this to making sure the people do it, and I don't know if that's coming down the pipe, or if it's just going to stay with this voluntary, well, I guess it's not voluntary, but just going about it this way. So I mean that's the same for any landing, where a decontamination station is present. Technically, if you don't do it, you're breaking the law. This is just one example of where they're providing it for a specific event.
Okay, thanks, Colton. We're out of time, but we do have some questions coming through the chat if you wanted to pop in there.
Yeah, and one thing on
Sure.
that quick. So I'm actually the one sharing the presentation. That's why I wasn't the one saying next. But so I don't want to mess anything up, so I'll get to the chat later.
Okay,
I'm not
sounds good.
ignoring your question. I'll just get to it later.
Okay, thank you, Colton. Next is Sandy Swanson. Sandy Swanson is the president of the Mackenzie Lake Association in Burnett County and Washburn counties. Sandy will be discussing the Mackenzie Lakes efforts with handling zebra mussels and just living with zebra mussels on a daily basis. So, Sandy, if you want to take it away.
Thank you, Emily. I have my mute off. Can everyone hear me okay?
I can hear you just fine, Sandy.
Great, thanks. In October of 2016, a shoreland owner reported finding 2 adult zebra mussels on a removed section of dock on Big Mackenzie in Washburn County. The regional DNR station in Spooner was notified and verified it was a zebra mussel. A DNR rapid response grant was applied for by the Mackenzie Lakes and granted in April of 2017. The 3-year, $20,000 rapid response grant required the following 4 activities by the MLA. Monitoring of the population of zebra mussels on all 3 of the Mackenzie Lakes, watercraft inspections, decontamination, and educational activities. The MLA formed a Zebra Mussel Committee to enforce and implement and monitor the 4 required activities of the grant. Additionally, 2 MLA board members also served on the DNR's Zebra Mussel Management Committee to keep the members of this committee informed and to work in partnership with any activities required. So 2017, next slide, please. Thank you. Monitoring of the zebra mussel population. In April, the zebra mussel alert signs were ordered and installed at the 3 public launch sites, warning of the zebra mussel infestations and instructions on how to clean and decontaminate the watercraft. Next slide, please. Zebra mussel monitoring plates were purchased, and 38 zebra mussel plates were deployed throughout the 3 lakes in early May. Plus, 1 plate was sent into each Sentinel Lakes, which are connected to the Middle Mackenzie area, Lindy Lake, which is west of Middle, and Mystery Lake, which is just north of Middle. Plates were distributed to lakeshore owners. They were provided instructions on how to place the plates, check the plates, and report any results to the committee twice that summer, the middle of the boating season about in July, and when the plates were removed from the lakes. Next slide, please. 25 plates were deployed on Big, 9 on Middle, 4 on Lower. Reported findings in 2017 were just a few to maybe 100 on each of the plates in Big. There was none reported on Middle and none reported on Lower. Watercraft inspections in 2017. The MLA committee worked with partnership with the Washburn and Burnett County AIS coordinators to set up a schedule to staff the public launch sites on Big and Middle, with the emphasis being on Big. MLA members were trained in clean boat, clean water inspections and provided the volunteer time to match the grant. Additional inspections were provided by paid personnel from Washburn and Burnett AIS departments and from state wardens. Next slide, please. Decontamination. This is still 2017. The committee investigated to determine the best methods to provide decontamination of watercraft leaving and entering the lakes. The committee determined that the best method to provide the decontamination to the majority of watercraft leaving and entering the lakes would be to set up a self-service decon station. Because the 3 lakes are in 2 counties and 3 townships, the committee proceeded to 1, determined the legal ownership of each launch site. 2, met with the different town boards. 3, received permission for boat inspectors and erecting the decon signs. 4, purchased a liability policy for the MLA. 5, a member of the MLA who is a graphic artist coordinated with the committee for the sign wording, the design, and the color. By midsummer, decon signs were ordered for each of the 3 launch sites and were installed. Garden sprayers, brushes, and hooks were purchased. The committee had a weekly schedule signed up for volunteers on each of the 3 lakes to check and replace the bleach water solution as needed. In 2017, I'll touch just a little bit on informational education, which was part of the Rapid Response Grant. We saturated the market with social media, with our emails to members, our MLA website. We had members speak at our member meetings on zebra mussels and AIS. We had an informational table set up at our annual Booyah fundraiser. We are very fortunate that a committee member and a member of our MLA is a PhD biology professor at UW River Falls. He gave us a zebra mussel presentation at both our May and September member meetings, and he kept the committee and the members informed throughout the whole summer and boating season with articles on our website. We'll move ahead to 2018. MLA contracted with Burnett County to provide paid, trained boat inspections at the public landings on Big and Middle, starting with Memorial Day weekend. MLA reimbursed Burnett County for the paid inspectors through the Rapid Response Grant. Volunteers, Clean Boat, Clean Water boat inspectors were sent to Lower. And also in Big and Middle, when the paid inspectors left for the college in August, or their college days in August, volunteers were sent to all 3 landings also. The information was collected on inspection sheets given to the grant administrator who entered the stats into the SWIMS database. Next slide, please. This is representative of a boat lift removed from Big Mackenzie in the fall of 2018. You can see the black dots covering the lower parts of the lift that would have been in the water. The aluminum above on the top section of the slide is the part of the bunks and the top part of the lift that would not have the zebra mussels attached. Next slide, please. This is a plastic tire from a boat lift on Big Mackenzie in the fall of 2018. The zebra mussels have entirely covered the tire, or the rubber tire, or the plastic tire. This is not unusual. I received 15 or 20 of these pictures from members on Big during the course of the fall season when they pulled their lifts out of the water. Next slide, please. 2018, the committee set up a weekly volunteer schedule for each of the 3 launch sites. Each station was monitored daily. The schedule started in May and continued through middle of October. This is the decontamination, where the sites, the signs, the decon signs, and the signs were set up to wash your trailer and your bottom of your boat before going in the water and when leaving. Next slide, please. And It's the Law sign was attached to each of the decon stations at each of the launch sites after the decon became a part of the county transport law. 2019. This was the last year of the Rapid Response Grant. The administrator set an inspection schedule for both paid and volunteer on Big Mackenzie using the remainder of the Rapid Response Grant funds. MLA received a Clean Boat, Clean Water grant to staff the Middle Mackenzie with paid and volunteers starting Memorial Day weekend. A contract was signed with Burnett County to hire and pay the boat inspectors for both Big and Middle. MLA reimbursed Burnett County for the paid inspectors through the balance of the Rapid Response Grant for Big and the matching grant for Middle. We didn't have the capabilities and didn't want to enter into the position of having to pay the paid people with checks and with keeping track of hours and possibly different kinds of withholding. So this was the best arrangement for us at the time. Decontamination in 2019. We continue to see an increased usage from spring to fall with heavier use on weekends, of course, which would be expected. Boaters have now seen similar decon stations at launch sites in Minnesota and other Wisconsin lakes, or were approached by boat inspectors, so they were becoming more aware of the decon procedure. The years 20, 21, and 22, we did not have the Rapid Response Grant. Each of those 3 years, a grant coordinator was instructed to apply for a grant and was granted a grant for the 3 lakes. Now we've added Big, Middle, and Lower into one grant, $12,000 with $4,000 at each site. The previous fall, Burnett County had informed us that they would no longer hire or pay the boat inspectors. So we approached the Township of Scott and an agreement was reached. 1, the Clean Boat, Clean Water Grant Administrator would interview and train the inspectors. 2, the town would hire the inspectors and pay them on the town payroll. At the end of the boating season, the town of Scott invoiced MLA, and we paid the town of Scott through the matching grant. The grant administrator was fully responsible for supervision of the monitors, setting the schedule, interviewing and training the inspectors. Some of the inspectors that were paid were college students earning summer money. Some were retirees wanting spending money. 4 were cabin owners who just wanted some extra spending money through the summer. And we did have some high school students as well that were paid. The matching volunteer hours were MLA volunteers from each of the lakes. The fall of 2022, when the plates were removed and inspected by the homeowner and by the committee, we continue to see thousands and thousands of zebra mussels on the plates. On Middle, we did see a decrease. I think as it was mentioned in one of the previous presentations, we saw a decrease that the monitoring plates from Big did show fewer zebra mussels. Middle continued with Lower continued with 0 on all the plates on Lower. The impact on the Mackenzie Lakes. Maybe here's some cons. Big and Middle since 2017. Reported counts on the monitors in Big Mackenzie have increased from a few to thousands. Plate report monitors too many to count on all plate reporting on shorelines around Big and Middle. In 2018, Middle had 1 monitor plate with 2 adults. So now let's fast forward to 2022, where all plate reporting on Middle seems to follow the trend as on Big, with thousands on each plate around the lake. In 2022, on both Big and Middle, we saw adults on dock legs, boat lifts, and bottoms of watercraft. Cabin owners are taking hours to scrape zebra mussels from the watercraft before wintering at the end of the season. Zebra mussel adults are also attaching to rocks, tree limbs, branches, and vegetation. Fishermen are reporting zebra mussel adults attached to vegetation on their fishing lines. In 2022, boaters are reporting pieces of zebra mussel shells broken up on the shoreline on Big Mackenzie at West Point. That's the peninsula that juts out in Big on the west side of the lake. I guess we do have some pros, and I tried to find some pros. The water does become more clear. We've talked about that before. The water readings on both Big and Middle have been clearer between 21 and 22. Lower Mackenzie has stayed the same on the second reading. From statistics that we have on real estate, cabins and lake home values have not decreased. Sale prices have stayed pace with other real estate sales in this area. Next slide, please. Because of lake size and location close to the Twin Cities, the Mackenzie Lakes continue as a destination. More people is a combination of more bigger boats, bigger pontoons, seasonal cabins converted to year-round usage, and larger lake homes being built. Next slide, please. It's different on Lower Mackenzie.
Sandy, this is your 3-minute warning.
Thank you.
Yep.
It's different on Lower Mackenzie. Smaller in size, less boat traffic in and out, but it tends to be fishermen there for the day for the bass and panfish. That's why it's going to be very important for the decon stations and the boat inspections to continue, not only on Big and Middle, but the launch site on Lower is vitally important. Living with zebra mussels today. There's no method to rid them in either lake as far as we know. Owners on Lower are hopeful that they will not see them possibly based on the chemical composition of the water. We don't know as yet. On Big and Middle, some lake owners are becoming weary and have adopted a laissez-faire attitude, but some are possibly the ones that would be that way anyway, no matter the problem. They don't engage. They may be the ones who don't belong to the association or attend the meetings or volunteer. However, we have an overwhelming number of responsible lake owners who care about the Mackenzie Lakes and will respond in a positive way to any new suggestions to control and live with zebra mussels until a solution is found. MLA is committed to reaching out, increasing awareness, continuing educational presentations at our meetings and our newsletters, and connecting through members and non-members through our MLA website. Last slide, please. Any questions?
Thank you, Sandy. We do have 2 minutes and have time for questions. One just came through from Eric. He asked Sandy, how many hours per year did you have inspectors at the 3 launches in 2022? And have you worked with Washburn County Sheriff for boaters that do not decontaminate?
First question. The $12,000 grant amounts to, this is approximately now, 250 paid hours on each of the landings, and then the amount that would have to match that around 56 to 60 volunteer hours on each of the 3 landings. I have people that will do Friday afternoons, Saturdays and Sundays. They are 9-hour shifts with 2 people, 1 morning and 1 afternoon shift. I just don't have enough paid or volunteer to do a weekly or during the weekdays.
And then the second question was, have you worked with the Washburn County Sheriff for boaters that do not decontaminate?
Yes.
Yep. Okay.
They have been called. In fact, myself personally did call Washburn County twice, and they came, and it was they asked me to just step aside and not say anything, but it worked out very well. They were able to de-escalate the situation, and the boater did decontaminate before they went in. In the second instance, the boater decided just to leave.
Okay, thanks, Sandy. And the other things in the chat are just a wow, great presentation, and thank you, Sandy. So
thank you.
Thank you very much. And that concludes our morning session, everybody. We just hit lunchtime, and our lunch goes for 45 minutes. We did put together a slideshow of pictures that you guys can enjoy while you have your lunch. Feel free to log off and have lunch if you prefer to do that. I just wanted to thank all of the morning presenters with those great presentations and for all of the questions that the audience has sent in. And with that, Caitlin or Colton, if you guys wanted to add anything, feel free.
Yeah, the only thing I just wanted to add again, if you missed the welcome, was that we are recording the forum today, and so we will send out the link to everyone who did RSVP with Colton. But if you didn't RSVP and you just got the link shared with you, that's just fine too. You just have to let us know, email Colton or myself, and we'll be sure to send you the link when it's available.
And Emily, I'll stop sharing my screen now if you want to start the lunch presentation.
Okay, thank you. Let me know if you can see my presenter. Is that good?
Perfect.
Perfect. Thanks again, everybody, and see you at 12:45.
Alrighty, everybody. Welcome back from your lunch break. Before we get started again, just like to go through a couple housekeeping things. This is being recorded. So again, if you didn't RSVP to colton.sorensen@polkcountywi.gov, make sure you do so you'll automatically be enrolled to get that recording. If a few of us are new joining in, we do have a chat feature with Teams, and we'll be using that to ask questions, share information, and interact with speakers. At this point, I would like to turn over to Emily to introduce Paul.
All right, thanks, Colton. The afternoon sessions are going to be getting into the zebra mussel monitoring and management efforts. So our first speaker is Paul Skowinski. He's our statewide Citizen Lake Monitoring Network educator with the University of Wisconsin-Stevens Point Extension Lakes program. And Paul will be introducing zebra mussel monitoring techniques volunteers can use on the lakes they live on. So take it away, Paul.
Thank you, Emily. I'll just mention that the chat for me earlier today was kind of slow, so I wasn't seeing things as soon as they were put in the chat. So someone else will have to maybe push the questions toward me if they come in.
Yeah, I'll do the chat function for you and let you know if you have any questions at the end.
Sounds great. Thank you. All right, so zebra mussel monitoring is part of the Wisconsin Citizen Lake Monitoring Network. It's a much larger project than that, but we have two different ways that we monitor for zebra mussels, and I'll be talking about those two different methods and how they differ and when we use each one. So first of all, the Citizen Lake Monitoring Network in Wisconsin is actually one of the largest and longest running volunteer water quality monitoring programs in the nation. We started in '86 with 113 lakes that were just doing water clarity monitoring. So they were lowering a Secchi disc down into the water, seeing how far down in the water they could see the disc and measuring water transparency that way. And we still do that. That's still our most popular part of the network. And we still use the same method and the same tool to do that. We currently have 1,000 volunteers participating per year in the network, monitoring water clarity, but also water chemistry, aquatic invasive species, native aquatic plants, ice duration, many other things on lakes as well. So it's a large program, and AIS monitoring is a small piece of that. Our biggest data set that we have as part of the network is over 210,000 measurements of water clarity taken since the program began in 1986. And this data set has been used for everything from an individual lake management plan to national and continental scale studies of water quality trends. So it's really been cool to see how that data has been used on such a huge scale and really not only informing an individual lake's management, but informing limnology as a whole, as a part of science across a huge geographic range. So as far as zebra mussel monitoring goes, we have two different methods that we use. The first is a presence-absence monitoring. So we're just detecting whether zebra mussels are present in the water or not. And previous to last winter, we used a PVC plate sampler. This is similar to the photos that Sandy showed earlier. And we now use a slightly different method. If you're already using a PVC plate sampler to do presence-absence monitoring, you can continue doing that. There's nothing wrong with that. But from here on out, we're using a new method that uses a brick instead of a PVC plate sampler for the presence-absence monitoring. And the reason for that was that the PVC sheets are expensive. They're difficult to store, to cut, to ship, and bricks are cheap and they're available anywhere. And so we move toward this faster and just easier method for volunteers. We're always trying to make things easier on the volunteers if we can, revising methods as we get feedback from volunteers and can come up with some easier methods. So what we do with the brick is, or the PVC plate sampler, is to lower it on a rope from a pier, and we lower it 1 foot off the lake bottom, and you leave it there for a month, and then you pull it back up and you scan it visually and feel it with your fingertips to see if there are any zebra mussels attached to that brick. If there are not any, then you just lower it back for another month and pull it up again and take a look for it. For zebra mussels. If you do find them, then we ask that you take pictures of the brick and also some zebra mussels on your hand or something else that gives us a sense of scale, and email those photos or deliver them to your AIS coordinator or the regional Citizen Lake Monitoring Network coordinator for your area. And if you do find them, we would move you then toward the other method that we use, the quantitative or population level monitoring. So that method uses the PVC plate sampler still, and this was also revised the winter of 21-22 to be a faster and easier method. You heard Sandy mention a couple of times that people report that there are just too many to count. And what we were asking is volunteers to count the number of zebra mussels on each plate and then measure some of them as well. And that's time consuming, and it can be downright impossible to count thousands of zebra mussels on the plate sampler. And so we revised that to be a much faster method now to still give us some density trends, but not require individual counting of the plates. So we still require a pier and the sampler itself, and then we suspend that from a rope. So it's a similar method, still hangs 1 foot off the lake bottom. The reason for the 1 foot between either of these methods is that we don't want snails and turtles and crayfish and things interacting with the plates as well, because they can just foul the plates. They could potentially eat zebra mussels. I've personally watched turtles eat zebra mussels off of rocks before. We want a pretty representative idea of how many zebra mussels are really colonizing those plates. And so if things are eating them or competing with them in other ways, then that's giving us an unrealistic picture. So this sampler is left in through the entire season, and you pull that up in September and take it apart. So there are 4 sheets and 4 spacers in between the sheets and a bolt that holds it all together. So you take that apart and you, again, scan and feel the top and bottom side of each plate. And we're looking for zebra mussels and the abundance of them on each plate. So what that does for us is gives us an idea of the changes within the population. We want to know, how is the population changing over time? This starts getting into what Maureen talked about before, what Greg talked about before. This long-term monitoring is really important, and it can start to relate to other variables within the lake to give us an idea of how zebra mussels are impacted by other changes within the lake. It could be biological changes, it could be physical changes like temperature. But having this long-term record of zebra mussel population is really important to be able to relate that. If you listen to Greg's talk earlier, he did a great job illustrating just how complex lake systems are, and it's hard to say that one thing caused something else when there's so many things going on in a lake at one time. So it's really important to have that long-term information on zebra mussels, or whether it be Eurasian milfoil or water clarity or any of those things. When you check a plate sampler, these are a couple examples of what you might find. The ones on the left are fairly large zebra mussels, fairly easy to see. They've got the distinct banding on them, the capital D shape to the shell. The ones on the right are very young. They've probably only been settled on that plate for a matter of a couple of weeks. They're very small, don't even really have the capital D shape too much yet. They basically look like grains of sand. The only difference is most of the colonization tends to happen on the bottom side of the plate. A lot of them are hiding along the edges or on the underside. So you wouldn't have sand on the underside. And the sand, if it was sand, it would fall off the plate readily in the water, or you could brush it off. And these ones are going to be a little bit stuck to the plate. So that's how you tell that it's not sand. But this will just give you an idea of what the plates can look like when they're colonized. And this is what we ask for now. Instead of counting them all, we have a density scale. So you see there are top and bottom lines for each of the 4 plates. And for each one, we just ask the volunteer records a 0, 1, 2, or 3. And you can see this, the legend there. 0 is no mussels, 1 is less than a third covered, 2 is between 1/3 and 2/3 covered, and a 3 ranking is 2/3 to completely covered on that side of that plate. And then there's some basic habitat information at the top, just giving us an idea of what the habitat was like where that sampler was placed. But this is a much faster method. It takes a fraction of the time that it used to. So we hope that it's a much easier and more enjoyable experience for the volunteers. If anyone has used the new form, we'd be really interested in hearing what your thoughts are on the form, how you like it compared to the previous method. So let me know, let Maureen know. Either one of us will share with the other person, and we'd be happy to hear that feedback. So as far as the data entry goes, all this data goes into the Surface Water Integrated Monitoring System. That's the state database for surface water data. All of our volunteer and staff data all go to the same place. And this is where it would end up getting entered. So it can be done by yourself. You can get a username and you can enter that yourself. Some lakes have multiple people monitoring and they give their data to one person, and that person does all of the data entry on behalf of that lake. You can also scan your data sheet and email it to me or to Colton or Caitlin. or mail it in to somebody. We have different ways that we can get into the database depending on how comfortable you are with doing it on your own. The last thing I wanted to mention was that we do have a video on zebra mussel monitoring methods as part of the Citizen Lake Monitoring Network. We've been putting together these videos for all of the different parts of the network, so you can quickly see how this is done if you'd like to get involved, or use it as a refresher in the springtime, because let's face it, winter is long and sometimes you forget a few things over the winter and need a quick refresher in the springtime. So this video is out there on our Extension Lakes YouTube channel. I've got that on my next slide as well, but you can just go to YouTube and search Extension Lakes and you'll find our channel. And we have hundreds of videos of various lake topics. I think I have 2 or 3 minutes left if there are some questions. Otherwise, here's my information. Feel free to email me at any time. I am working part-time at home and part-time at the office, and I'm on the road a lot. So usually email is the best way to get a hold of me no matter where I'm at. But please do contact me if you have any questions.
All right, thanks, Paul. Yeah, we do have 2 minutes for questions. It looks like Lisa Burns was wondering, how do lake associations get the plate samplers? Do you ship them?
Yes, they are currently being shipped from Rhinelander through Sandy Wickman, so contacting Sandy would be the best way to get them.
Okay. That was the only question in the chat. We do have time for a question or two. Feel free to put them in the chat.
Somebody's got to ring the doorbell when I'm talking.
Mark asks, when you are doing population monitoring, how many plates do you recommend?
Yeah, that's a good idea, or a good question. Some lakes are more complex, and if you have multiple inlets or outlets, sometimes the zebra mussels will be concentrated in certain areas. So we might suggest multiple plates depending on how many of those outlets and inlets there are. If it's a typical circular bowl-shaped lake, one is probably just fine. Other lakes with more bays and inlets and things, as I said, would be reason to put out more of those. So there's no one number. Some lakes might do, I don't know, 5, 6, 7, 8. I think the Mackenzie lakes have much more. They purchase their own. Typically, we would look to provide probably 2 to 3 per lake, unless there's a really unusual situation with a lot of bays or inlets.
Okay, thanks, Paul. I think we're out of time. Thank you for your presentation, and if there is any other questions in the chat that pop up, if you just want to pop in there and check that out.
Sounds good.
Our next speaker is Marion Schaefer. She is an aquatic biologist with the Natural Park Service. If you want to put your slides up, Marion. Perfect. She's going to be talking about the zebra mussel veliger tow efforts the St. Croix watershed and affiliate partners have been working on. So go ahead, Marion, whenever you're ready.
Thank you. Hello and good afternoon. I'm Marion Schaefer, the aquatic biologist at the St. Croix National. Oh.
Marion, you're just a little quiet. If you want to speak up just a little bit louder.
Okay, can you hear me now?
Yeah, that's a little better. Thank you.
Okay, sorry. I've been having issues with my microphone. So I'm Marion Schaefer, the aquatic biologist at the St. Croix National Scenic Riverway. I work on all kinds of fun things at the Riverway. Invasive species is just one component. But today I'll be sharing our zebra mussel monitoring activities within the Riverway that have occurred over the last 20 years. This work is supported by the U.S. Army Corps of Engineers and our official nonprofit partner friends group, the Wild Rivers Conservancy. So here's an outline of my presentation. I originally was just going to discuss our veliger sampling, but I thought it would be beneficial to cover the whole suite of gears we use to sample all life stages, just to give everybody the full picture of what we do and the levels of recruitment in the watershed. We also sample adult populations over time to monitor changes in density. But first, I'd just like to spend a little bit of time introducing our beautiful riverway to you. So the St. Croix National Scenic Riverway was one of the original 8 rivers protected under the Wild and Scenic Rivers Act in 1968, and it includes its main tributary, the Namakagon River. In 1972, the lower St. Croix National Scenic Riverway was added, and this includes the section of river from the St. Croix Falls Dam down to Stillwater. So the outstanding remarkable values, or ORVs, for the which the riverway has been designated as a wild and scenic river, are its free-flowing character, exceptional water quality, and the aquatic, riparian, recreational, cultural, geologic, scenic, and aesthetic values present in the rivers. The riverway borders northwest Wisconsin and eastern Minnesota. The St. Croix watershed as a whole spans over 7,700 square miles across these 2 states. The riverway encompasses a total of 255 miles of unpolluted waters, which flow through some of the most pristine and undeveloped country in the upper Midwest. The watershed includes 20 counties in Minnesota and Wisconsin that line the riverway, and we work closely with each of our county partners on conservation efforts, including monitoring for zebra mussels. The system is very biologically diverse, with 3 different ecotypes that overlap and intertwine along the riverway. So we've got the northern coniferous forest, eastern deciduous forest, and then pockets of prairie. Then in the south, it also meets up with a large metropolitan area that's full of life in its own way. So the St. Croix River, as I said, is known for its aquatic ORVs. It has one of the most exemplary freshwater mussel species assemblages within the nation. The river has 41 native mussel species, the same 41 species present prior to European arrival, 5 of which are federally endangered. We have some really exciting ongoing projects with the USGS, Fish and Wildlife Service, and the Minnesota and Wisconsin DNRs, where we're working on the propagation of these species as we learn more about their host fish distributions and interactions. So unfortunately, the zebra mussel found its way into the St. Croix River in 1995 and were first discovered reproducing in the river in 2000. Zebra mussels pose a major threat to the diversity of native mussels and therefore the integrity of the system overall. Zebra mussels affect native mussels by competing for food and attaching to mussels in such numbers that infested mussels cannot travel or burrow into the sediment. They also can neither open their shells to properly respire or feed or move, and then they can't close their shells for protection from the zebra mussels or other threats. So to monitor and better understand river level or river population levels, we teamed up with the Wild Rivers Conservancy, and we've measured zebra mussel density and recruitment over the last several years. Newly settled populations are passively sampled on an annual basis using artificial concrete substrate in the lower riverway, and those are marked by the maroon or red markers. In the upper riverway, we use settling plates deployed at impoundments for early detection and to determine presence absence. Those are marked by the orange dots. And then we also conduct the veliger sampling basin-wide and in the lower riverway. And those are represented by the blue markers. So annual measurements of densities within the known infestation zone, or the lower 22 miles of river, have been collected since 2014. Passive samplers are deployed on the river bottom at strategic locations from Stillwater to Prescott, and this is reflecting the range of habitats and hydrology found in the infestation zone. Substrate samplers consist of 3 linked cinder blocks deployed at each site, and then we cage them with chicken wire to prevent predation by fish, like we learned about earlier in the day. Common carp and freshwater drum and other fish species do eat zebra mussels. Samplers are deployed in May and then retrieved in October. I just really like this picture on the right. It was taken at the Mississippi confluence near Prescott, and you can just see the stark contrast of the 2 rivers colliding. Just another map showing the 10 block sampling locations. And it also shows the 4 pools of Lake St. Croix, which is a much wider section of the river and very much a lacustrine environment. After the introduction of zebra mussels, NPS instituted a zebra mussel access control point prohibiting boat travel upstream from river mile 29.5, which is where the High Bridge is located, just north of the boom site in Stillwater. Currently, so our most northern block site is at the Heron Rookery there, by the boom site, and then our most southern site is at the Mississippi River confluence. So after retrieval, zebra mussels are counted and measured. And here's a photo of our awesome counting crew last year. Huge thanks to the Conservation Corps and the Conservancy for knocking out, counting all of these blocks in just like a matter of days. So here are some results. This is our 2022 results. We saw the highest numbers at the confluence with the Mississippi, over 62,000 zebra mussels per square meter. Second highest numbers were at Lake St. Croix Beach, which I said earlier is a more of a lacustrine or lake-like environment. Our lift bridge sampler was hit and dragged as data was omitted. In all previous years of sampling, I just wanted to make a note that 0 zebra mussels have ever been found on the Heron Rookery block samplers, our most northern site. However, this year we did find one individual attached to the blocks, just one, and so we're not sure if that was just an incidental, like a zebra mussel fell off of a boat motor, perhaps by a boat motoring by, or if the range expansion. But yeah, here you can see the increase in density as you progress south closer to the Mississippi confluence. Pictured is one of the blocks retrieved at our Prescott site, just to give you an idea of coverage and infestation, just the layers and layers of mussels. Across all sites, 93% of zebra mussels measured less than 10 millimeters in length, indicating majority of the zebra mussels were younger and were more recent recruits, so likely mid to late August recruits. And we have been seeing 2 waves of recruitment in the St. Croix. So we have one early summer wave and then another late summer wave of reproduction. This is a time series beginning in 2014 when passive block sampling commenced. In 2019, you can see a significant increase in density at Afton or Black Bass Bar and St. Croix Bluffs. Then in 2020, numbers skyrocket. 2020 was a particularly low water year. In 2021, numbers decreased across sites compared to 2020. We had a slightly higher year for water levels, and now this year, you can see numbers have skyrocketed across the board, and this was a record-breaking year for low water levels, which may be correlated. So in 1,000 marinas that operate on the lower St. Croix River, and several of these we visit every fall to examine boats that have been pulled out to be dry docked for the winter. And we examine about 100 boats in each marina for the presence of attached zebra mussels. Marina slip boats offer the perfect substrate for settling post-veliger animals, and therefore they provide an opportunity to assess relative abundance. So we conduct this sampling every year in November. And here are some of the results. So just like in past years, marinas that had boats docked in the upstream portion of Lake St. Croix tended to have less boats with 1 or more animals attached, while boats moored downstream had a greater than 50% chance of being pulled from the water infested. So this suggests within pool reproduction and recruitment occurring. You can see here that Hudson this year had 100% coverage. Afton, Windmill, and the Miss Croix marinas also had nearly 100% of the vessels covered. This is a 22-year time series since these surveys began in 2020 or in 2000. We have higher numbers in 2022 than ever seen in previous years. Numbers remain floating around the 50% coverage area for a few years. Then in 2021 and 2022, we see a huge jump up by 25%. And overall this year, 76% of vessels were covered. So we have to wonder if this is correlated to the record low water levels that we've been seeing during the zebra mussel reproduction and recruitment time windows. We have many questions that we hope to answer. But here on this time series, you can also see the boom bust cycles of the zebra mussels in the system that Maureen talked about a little bit earlier. So PVC plate samplers were deployed in the upper riverway also from May to October. These included the Namacoggin, Hayward, Trigo, and Gordon dams. Luckily, no zebra mussels were found to be attached to these samplers. In 2022, we sampled zebra mussel veligers using 2 different methods: quantitative sampling in the river via handheld pumps And this occurred at 7 river locations from St. Croix Falls down to Prescott. Qualitative sampling occurred via plankton net tows with 66 micron mesh on 49 different lakes throughout the watershed. We also started sampling for a new critter, aggressive critter called the spiny water flea. We screened all samples and all came back negative, luckily. I just want to give a big shout out to the Conservancy staff and including Maria Young. They did most of this work and I feel she should be presenting the results, but I'm presenting in her place of her.
This
So
is
the same.
Marion,
Yep.
this is your 3-minute warning.
Okay. Oh, darn it. Okay. I'll go really fast. So the same lakes which had previously tested positive again, Big and Middle Mackenzie Lakes, Deer and Comfort. We did see a large increase in the concentrations at Deer Lake, which I'll touch on in a minute. These are all the results from 2022, just so you can see the range, like all the different lakes and counties that we cover. We did see, here, I'll go to the next slide so you can see the breakdown. We did see some increasing trends in concentrations and decreasing. So we're seeing different lakes that are having increasing trends and others that are having opposite. So it's not the same across the board by any means. Here, I'll just give a little more breakdown. We had a new detection at Balsam Lake. So comparing from year to year, Deer Lake, we had concentrations that increased from 0.003 in 2019 to 14.2. So we saw a large increase there. There was no veliger detection at Lake Wapo. However, my colleagues have shared that we have seen adults there. And this is a little alarming because these lakes are all connected to the Apple River, which ultimately flows into the St. Croix, which is actually near some sensitive populations and restoration sites for endangered species. So we'll continue to keep close tabs on those populations. So up by the Namakagon River, these lakes that continue to come back year after year as positive have been seeing different trends. So lower Mackenzie veligers are still absent from that lake. In Middle Mackenzie, we went from seeing absence in 2019 to now an increase up to 9.20 per liter. Big Mackenzie, we saw actually a decrease from 87.4 down to 0.2. And then in Comfort Lake in Chisago County, we saw a decrease from 1.53 down to 0.011 in 2022. So that's good. No, you don't need to see any more maps, but this is just a map showing the current positive basin-wide zebra mussel veliger locations. So our conclusions, well, we're still kind of scratching our head, trying to figure out their story, but we may be beginning to see the beginning stages of a range expansion. We're seeing increase in adult densities in the river, which may be attributed to environmental factors, including hydrology and low water levels. The St. Croix is unique that it's a flowing system. So if we have a high water flood year, that's good. And that's the norm. And the veligers have a harder time settling. And so they kind of get flushed out of the system. So we're looking to answer some more scientific research questions like what environmental drivers are keeping them at bay at the Stillwater area there? Is it nutrient availability, water levels, etc. So we're going to be exploring that further. We're going to be enhancing our veliger sampling around that area to try to pinpoint the adult population in hopes that we can maybe try to mechanically remove some of those individuals. So, yep, we need to keep a tight pulse on these patterns of zebra mussels. It's our duty to preserve and protect this amazing place. And so I'm going to try to keep fighting the good fight. Just wanted to share, continue to practice prevention and spread the word to others. Huge thank you to our regional partners. We couldn't do this without you, and to all the staff and technicians that have helped and risked their lives on windy days on the river to deploy and retrieve cinder blocks. Thank you for all of your hard work. And there's my information if you have any questions. Thank you.
Thank you, Marion. Awesome presentation and great work. Fortunately, we are out of time, but if you wanted to pop in at the chat and see if there's any questions, I think there'll be some questions for you. So thank you again. Angelique is up next. If you want to start sharing your screen. Angelique, hi. Angelique is a PhD candidate in the Conservation Sciences program at the University of Minnesota, and she will be presenting on zebra mussel control research implemented at the University of Minnesota. So the floor is yours.
Okay, I just want to confirm, are you looking at the presentation itself, not the presenter view?
Yes, I can see your presentation and you sound good.
Perfect, excellent. Okay, thank you. Well, thank you everyone for being here and listening to what I have to say. And thank you, Emily, for that introduction. So as Emily said, my name is Angelique. I am currently working on my PhD at the University of Minnesota, and everything I focus on right now is on controlling zebra mussels. So today I'm going to be talking about different elements of my research, and I've put it in this framework of like if you were considering a zebra mussel treatment, specifically with copper, because that's what I research, what information should you consider? And briefly, I also want to acknowledge my my team that I work with. Dr. Nick Phelps is my advisor. Dr. Diane Waller with USGS is the project lead for much of my fieldwork and different elements of this research, and then a couple others with the USGS as well. I will also just very briefly acknowledge this work would not have been possible without the funding and assistance from all of the organizations listed up here. This is definitely a collaborative effort. So since I'm not the first speaker today, and I think you learned about zebra mussels starting with Maureen's talk this morning, and many of you probably have direct experience with them, I'm not really going to get into any background other than to highlight the difference between adult zebra mussels and one of their juvenile or larval life stages, the veliger. So on this slide, the adult is in the upper left-hand corner, and that's what you would probably find on a shoreline. The veliger form is down in the lower left-hand corner, and you wouldn't be able to see that or detect them with your naked eye in the lake. So currently, a lot of our focus is on preventing the spread and introduction of zebra mussels to new water bodies. And while that is a great strategy, it's not as helpful for those lakes that already have zebra mussels introduced. So today I'm going to talk about the options that lakes have for controlling zebra mussels once they've arrived. And just as a quick note, I'll talk about the concepts and research, but I do want to make it very obvious that local and state laws apply. So while some of the options that I discuss can be very effective and are real possibilities, they may not be permissible everywhere. Additionally, I'm not suggesting any strategy for any particular water body. Instead, I'll provide information to consider, with one of the big takeaways being that every water body is different and it's impossible to really make a general recommendation. So zebra mussel control efforts in open water systems like lakes have included physical, biological, and chemical methods. Physical efforts have included manual removal by divers, use of benthic mats to create anoxic conditions, drawdowns to expose the mussels. Biological strategies have looked at the effectiveness of fish, crayfish, parasites, microbes on reducing zebra mussels. When I popped in, Paul was talking about if you place the sampler plates on the bottom, sometimes you'll observe other organisms eating the mussels. So there are other animals in the water that will eat them. Biological efforts also include biopesticides such as Equinox. And then where my research falls is in this chemical control. And chemical efforts have used either potassium chloride or potash or copper-based pesticides. And it's those copper-based pesticides that I've been investigating. So focusing on copper has a long history of use in aquatic systems. We've been using it for centuries in some form. Historically, copper plating was used on boats as an anti-fouling agent to prevent the attachment of barnacles, such as on this image of the USS Constitution on the slide. Today, some paints designed for boats still contain copper. And beginning in the 1920s, researchers and communities in Minnesota and Wisconsin started using copper sulfate to control algae in different lakes. And what that looked like at the time was dragging burlap sacks of crystallized copper sulfate behind boats and just dragging those sacks through the water as a treatment. And while our technology and methods have evolved somewhat, they've definitely refined since then. I'll show you what we do today, that it's very similar to what it looks like back then, just greatly refined. But then moving through this past century, we see copper use expanded to include applications as like an algicide, a herbicide, molluscicide, used for macroinvertebrates, and against aquatic invasive species, including zebra mussels, but also quagga mussels, faucet snails, different invasive plants, and we still see it used for nuisance algae. So we've used copper for many years, and there's a lot of diverse knowledge out there on different copper applications. But how does copper work? So just a quick background chemistry of copper. I think this is important, especially if you're interested in doing anything with copper in a lake system. When copper is put into the water, it can exist as in a particulate matter form or in a dissolved form. And the difference is very simple. The dissolved form is smaller. So it passes through a 0.45 micrometer filter pore size. Essentially, it's dissolved as opposed to larger and particulate. When it's in that dissolved form, it can either be considered bioavailable or non-bioavailable. Non-bioavailable copper is typically attached to some type of organic matter, whereas bioavailable forms are able to interact with aquatic life. And the bioavailable copper forms are able to attach to sites on an organism's gill surface or gill membrane. And this is how we see the response of the organism to the copper. This is how copper acts on them. So copper ions, I know I'm kind of bombarding you with a lot of information on this slide, and I'll try to work through it. Copper ions compete with other ions for attachment at the gill site. I'm hoping, I don't know if you can see my mouse or not, but over on the right hand side of this diagram is essentially what you can think of as an enlarged gill membrane. And there are different ions that I've put up there. And there are essential ions that different organisms need. And when you add copper to the lake, copper competes with those other essential ions, and it changes how the organism is able to receive those other ions, and it competes with them. So just as an example, we often see that copper is less toxic in harder waters where there's more calcium to compete with. So all of this information about the water chemistry is important for determining what copper will do in the water too. And if you're wondering what happens to the non-bioavailable copper, a lot of that attaches to dissolved organic matter, which I said a couple of slides ago, and ultimately that copper ends up at the bottom of the lake in sediments. And once it's there, it can be recycled back into the water column, but for the most part, it precipitates out and gets locked into the sediments and remains at the bottom of the lake. And while I've been talking about copper in sort of an added pesticide form, we do have naturally occurring copper that also does all of this. So I want to acknowledge that it's not just humans adding copper strategically or not strategically. Copper does enter lakes via soils and atmospheric deposition and exits either through binding to sediments, like I showed in that previous slide, or being carried downstream to oceans. And then, of course, there's also the human component where we add copper. So now that I've talked about how copper operates in aquatic systems and why that might be useful for a zebra mussel treatment, I'm going to go through different things you might consider if you were thinking of conducting a zebra mussel control project. So we know a little bit about what copper does, and imagine we're considering a treatment. The first consideration you might have is concentration. What concentration of copper would you use? One of the most obvious things that you would need to take into account is the legal limit for application. With any pesticide, you have to adhere to laws, federal laws, local laws, including application rates listed on product labels. And copper-based aquatic pesticides have a law that they can be applied at maximum concentrations of 1 milligram per liter of copper, equivalent to 1 part per million. A second thing you might think about is which life stage you would target in a treatment. As is often the case with many animals, the young or baby stage is more sensitive than the adult stage. Past studies have found that killing 50% of veligers requires 53 to 64 times less copper than killing 50% of adults. Killing 99% of veligers requires 18 times less copper than killing 99% of adults. And exposure to 60 to 100 micrograms per liter of copper for 10 days kills almost all veligers and reduces settlement by 2,000 times. So big picture, veligers are more sensitive than adults by quite a bit. A third thing you might think about with concentration is the water chemistry of your lake. Since, as I showed with our chemistry diagrams earlier, copper toxicity does vary with water chemistry. So just recalling this diagram, chemical compounds in the water influence how much copper goes where. Breaking this down just a little bit more, we can think of it in terms of competition. So we've added copper. What are the other ions in the water that will directly compete with copper? What are the inorganic complexes present in the water that would compete with the gill membrane? And if you have questions about this, I'd be happy to chat more later. But the takeaway here is that the other ions and inorganic complexes in the water matter, and every lake is going to have a slightly different mixture of these ions and complexes. So we know that you can use that water chemistry, specifically this list of factors that I put up on this slide, along with some bioavailability modeling that exists to customize a concentration specific to an individual lake. And I'll sum the concentration idea up as an appropriate concentration depends on your zebra mussel age that you're targeting, as well as the water chemistry of the water body that you would be treating. The second thing that you might want to consider are non-target impacts. So copper is toxic to zebra mussels, but it's also toxic to many other aquatic organisms. And I've been involved in, I guess, a few studies now looking at how copper impacts other organisms at the concentrations you would use to control zebra mussels, including, I just put 3 of the projects I've been involved with up on the screen. We did a treatment on a bay in Lake Minnetonka in the Twin Cities where we treated an entire bay with a copper-based pesticide, and we studied the effects on 4 species of fish, on the benthic invertebrate community, on native mussels, and on the zooplankton community. I've also been involved with a toxicity trial in a mobile lab where we looked at the effects of copper on fish, again, a native mussel, a snail, and Daphnia, which is a zooplankton species. So we looked at it sort of in the wild. If you think of Lake Minnetonka as, it's hard to imagine that being in the wild, but in a non-controlled setting. And then we looked at it in a controlled setting. And I've also been involved with an extensive literature review looking through all of the information that we have to date from different studies worldwide on copper toxicity to aquatic organisms. And what we've found through all of this work is that there are some, at the concentrations we would use to kill zebra mussels, there can be some effects on fish. Fathead minnow had reduced survival after a 10-day treatment at 60 parts per billion copper. Largemouth bass, yellow perch, and bluegill really didn't show any changes in survival. In general, the effects to fish have been relatively small at the concentrations we've been looking at. We did also find some effects on invertebrate species. We looked at fat mucket mussels, both in the Lake Minnetonka experiment as well as in the controlled setting in the lab. And we found great survival among these fat mucket mussels. In our trial 2 summers ago in the controlled setting in the mobile lab, every single one of our fat bucket mussels survived under every single exposure concentration that we had determined to target zebra mussels. So it seems like they would fare well in a zebra mussel treatment. Banded mystery snails were the snail that we used in that trial. Initially, we'd been hoping to find a native snail. We were unable to find enough of a single native snail species, so we used banded mystery snail instead, and they appeared to have reduced survival at 40 parts per billion copper, although they didn't experience any effects at lower concentrations. So we saw that fat bucket mussels had very few impacts, while banded mystery snails were beginning to show an effect. And that was to be expected because copper is also used in snail control. We also found that after a 10-day exposure to 60 parts per billion of copper, total zooplankton abundance went down, but then rebounded pretty quickly. We saw some reduced Daphnia survival at 25 and 40 parts per billion copper, but no impact at lower concentrations. And we're still analyzing some community changes from the Lake Minnetonka work. It seems like there were some initial responses in the community composition, but that the communities returned to their original composition fairly quickly, and they were back to baseline by the following summer. So to summarize our non-target considerations, I guess my takeaway here would be to know which other organisms are in the lake and understand their sensitivities to copper. And think about like how a treatment might affect those species, but also how a continued infestation of zebra mussels might affect those species, and then determine how that fits into your larger long-term goal. A third treatment consideration is the location of your treatment. So where do you treat? If this is your lake, how do you decide where to treat? One fairly obvious thing to think about is how established your population is. So is this an early detection find where you found several adult shells in one bay of your lake, such as on the left-hand side of the slide? Or has the population been there for years with continued ongoing successful reproduction, such as the right-hand side of this slide? And then how do you know where the population is and how big it is? Usually if the population has been there for years, you know where it is. Usually it's everywhere. But if it's a new discovery, it's a little harder to define where that area of infestation might be. So in new discovery cases, you would probably want to use fairly rigorous and strategic detection surveying. Detection surveys that have been used in past control projects have included the surveys listed up here. I'm sure there are more that I have not included here, but we recently finished going through a fairly comprehensive, I guess I'll call it a list of different projects that have occurred throughout North America for zebra mussel control and distilled down main takeaways. And this list encompasses most of the survey methods that have been used specifically for zebra mussel treatment projects. All of these survey methods have different pros and cons, equipment, money, manpower, person power, skill level, and deciding which methods to use should probably be a very lake-specific decision. And in the end, you'd want to choose methods that will tell you where the mussels are and if there's reproduction that's happening. So what these surveys tell you will then help determine your course of action. For example, just walk through this example with me. If you have a lake with just a few adults found in one area, you would plan a very different treatment than a lake with adults found across maybe one entire side of a lake, or adults and villagers found throughout the lake. Maybe it was an early detection, but then you realized that that it's actually been there undetected for some time. So how and where you treat will be different for every lake. And then what do you do if your entire lake is infested? In fully infested lakes, we typically expect reproducing adults throughout most or all of the lake. And this changes how we think about treatment. You're no longer looking at just a small localized area to treat. Past projects have conducted what we can think of as full lake treatments. Highlighted on this slide is a section of the pesticide label for EarthTech QZ, which is a copper-based molluscicide. And the highlighted portion reads, when fish are present, do not treat more than 1/2 of the body of water at a time, starting near one shore and moving outward in bands so as to allow fish to move away. So assuming that your lake has fish, this means you can only treat up to 50% of the lake at a time. And there are several ways that you can work with this guidance. One successful way being, where it has been successful in some past projects, has been to treat the shallower areas along the entire shoreline, treating a sort of like donut shape is how I think of it. And the donut doesn't need to be evenly wide around the lake. It doesn't need to be circular. It's most strategic to follow the contours of the lake and treat the shallower areas where you're more likely to find the mussels. So typically that is along the perimeter. In areas where there's a steep drop off, you might not treat as far out, where in areas that are very shallow, or if there's a sandbar, you might treat a wider swath. And with that, I guess I'll also say it's worth considering, again, which life stage you're targeting and where they're located. It's worth considering things like wind patterns in lakes where the wind maybe always blows out of the northwest. Often villagers are more densely found along the eastern and southern shores. So if you're treating villagers, you may target one part of the lake more than another part. If there are currents at all within your lake, that may also affect where populations are found. So the geography and shape of the lake are also very important. And if you do have a localized population, you may choose to use a barrier. Using a barrier can add additional time, people, cost, but it can limit the spread and dispersal of the pesticide, potentially exposing the organisms to higher concentrations of copper for longer. And it may help protect other areas of the lake from exposure. So again, a very case-by-case decision, but it can be very helpful. In reviewing past control projects, we have 3 big takeaways for determining where and how to conduct a treatment, sort of 3 lessons from these past projects. The first is to evaluate the costs of a failed project versus the costs of a one-time over-treatment. Often a failed project, I guess, is either followed up by subsequent treatments or turns into a lake that is just long-term infested. So considering those trade-offs. The second lesson is to observe the effects on the whole ecosystem. It's easy to focus on just the zebra mussel part, but it's very important to understand the wider impacts. And then the final takeaway is to remember to do your post-treatment surveys, which I'll talk a little bit more about in a moment. Remember to do your post-treatment surveys as strategically and intentionally as your pre-treatment surveys. So if you spend a lot of time doing your pre-treatment surveys to figure out where the population is and how large it is and how many individuals there are, you want to set yourself up for after the treatment, then understanding how successful or unsuccessful your treatment was. So I'll sum this up as think about how you are going to determine where your population is located, and then set yourself up for after the treatment, determining how successful you were. The next treatment consideration I'll go through is the timing and duration of your treatment. In Minnesota, the dates of treatments have ranged from April to December. Some of these treatments have been well planned out in advance. Others are put together relatively quickly in response to a newly discovered infestation. In general, these treatments are a little more effective in the summer. It's easier to conduct the treatment, and the mussels are more active. They're respiring more actively. The product is a little bit more effective. And if you've decided to target villagers in your treatment, you would need to treat at a time when villagers are present, which would typically be in the summer. The durations of these treatments and whether or not there has been what we call a bump treatment have also varied. And a bump treatment is a subsequent treatment following that initial treatment just to help maintain the desired concentration. So as an example, the treatment that we conducted in 2019 on Lake Minnetonka, we initially we did a 10-day exposure to a copper-based pesticide. Our initial dose was to 100 parts per billion, denoted on this slide by a star. We started with a higher concentration. The overall maintenance concentration that we were aiming for was 60 parts per billion. We started with 100 with the expectation that a lot of that copper would be fairly quickly taken up by algae throughout the bay. And so we started at 100, and then every other day, starting on day 3, we did these bump treatments to maintain the concentration to at least 60 parts per billion. And we monitored the concentration in the lake to adjust accordingly. And so you can see from this slide, obviously we were striving for that dashed line. The reality looked a little different than the plan on paper, but in general, it wasn't that far off. And one of the challenges was the field equipment that's typically used is a little less precise than the equipment that's used in the lab. So we took measurements in the field and based our decisions off of those field measurements and then verified it in the lab. And it was a little higher in the lab than it had been in the field, which is useful for planning future projects. So decide what time of year is appropriate for your treatment. Decide what length of treatment is most strategic for your lake, and then decide if any bump treatments are needed. and how many might be needed. The project that I just mentioned, we did every other day treatments. Other control projects have treated once, maybe in June, and then they'll follow up with a second treatment a month later, and then a third bump treatment is, I guess, what they're considering it, in maybe a third month. So the duration and spacing out can vary. The next treatment consideration that I'll go through are sort of the mechanics of a treatment. I don't know that there's a right way to do this, so I'll just share what we did, what we have done twice now in Lake Minnetonka as an example. I think it's pretty comparable to other pesticide treatments. The scale might be a little different, but the treatment barge that we worked with looked like this. And when I break that down, what we see toward the rear of the barge are the totes of pesticide. And we also, I don't think it appears in this photo, but there is you can see it in the diagram at the bottom, there is a pump running up from the lake onto the barge, and that the pumped water then meets and mixes with the pesticide product in that yellow boxed area. And from there, it's carried to the front of the boat to a boom that's off the bow with those long hoses that reach down into the water. And the hoses deliver the product on this boat about 1/4 of a meter below the surface of the lake. And then essentially what we did was calculate the speed at which the boat needed to go to disperse the mixed product at the correct rate. And then the boat went at that speed back and forth across the lake, just like maybe mowing the lawn. And I'll also just say, as you're thinking about this, we applied early. We typically started at sunrise or as soon as it was light enough to see, and ended by early to mid-morning. The later in the day, the choppier the water, the more difficult the application. And in part because this was on Lake Minnetonka, although I think it probably applies to most lakes, the later in the day, the more boat traffic on the lake, and just the harder it is to go in a straight line across any part of a lake. So figure out what equipment to use. And that's just one example that I wanted to share. The last consideration for treatment I have is determining how you'll assess your success. And I kind of brought this up a little earlier, but what was your goal? Did your treatment meet that goal? How do you know? And what does that mean for next steps? One suggestion is to, at a minimum, use the same types of surveys after treatment that you used before treatment. How do your results then compare after the treatment to your results from before the treatment? In projects that are a response to an early detection, it can also be strategic to use more surveys after the fact. Often there isn't as much time before the treatment to do some of these. Like if you're going to put out settlement plates, that takes time to observe settlement. You may instead opt for other survey methods before the treatment, and then after the treatment, you can use those same survey methods, but also add in some of these slower monitoring methods. So plan for how you'll assess your results. And ideally, you'll do this before you even start the treatment. And I think I I have plenty of time for questions. I wasn't sure how many questions folks would have, so hopefully, Emily, hopefully this is a, you know, it's a bit long for questions, but
we should be good. We got some questions rolling in. Thank you for your presentation. That was a lot of good information to know. Our first question is from Joanne, and she was wondering, do copper and copper products affect native mussel species?
Yeah, they do. I touched on this really briefly. The one species that we used, fat bucket mussels, we didn't, at the concentrations of copper we used, we didn't see any effects. And so the highest concentrations that any of the projects I've been involved with would have been probably around 100 micrograms or parts per billion, micrograms per liter, parts per billion. So we did not see effects at that level, but they certainly are sensitive to it at higher levels or maybe for longer durations.
Right. Lisa Byrne asks, is there a better time of the year to treat than the other?
Yeah, well, yes. Some of the, especially the early detection finds, those treatments have typically happened shortly after the discovery, often like in the later months of the year, but I don't know. It seems like there's been pretty good success when it's midsummer, kind of that typical time when you think of targeting veligers to when water temperatures are warm. So yeah, midsummer would be my recommendation, but that's just specific to here too. I guess my USGS collaborators do work down further down south and out west where temperatures are different, and they do winter treatments out there, but it's much warmer. So
sure. Greg asked a lengthy question. Greg, maybe you just want to unmute. We do have about 16 minutes until our next presentation. So if you feel comfortable unmuting and asking your question, I think that might be the easiest solution.
Sure. I think, my main question, it kind of leads toward, I guess what the success is and kind of the thought of trying to reduce the amount of chemicals that we put into our ecosystem. So like on Minnetonka, with a small treatment on a lake the size that it is, I was kind of wondering, was that just like just experimental or research? Because obviously the zebra mussels will come back, so you'd have to just repeatedly continue to apply those chemicals. And then I was wondering about the impacts on humans, and if they're fully understood at this point. And then, some of these heavier metals, can bioaccumulate, and I don't know what the impacts of accumulation of copper are over time and if they can even accumulate.
Yeah, okay. So I'm going to try to go through each of those, and I'll probably ask.
Yeah, no problem.
Okay, so we've done 2 treatments on Lake Minnetonka. The first one in 2019 was in a bay of Lake Minnetonka that was relatively isolated from the rest of the lake. There was a small passage with a bridge overhead leading to the rest of the lake, but it was probably 20 feet wide or so largely isolated. And we chose that area because of that isolation. The goal was research. We wanted to see how low concentrations of copper affected veliger survival specifically. And so that was the treatment where we did a maximum of 100 parts per billion and then tried to maintain at 60 parts per billion for 10 days. And we found greatly reduced veliger survival. Our sampler plates were gosh, I think they were almost entirely clean at the end of that year and the following year, suggesting that this was a very effective concentration for veligers. We also saw a huge reduction in adult mussels. We had a scuba diver run transects on the bottom that year and the couple of years after that. We have since seen reintroduction, which was to be expected. So I guess the goal there was never to remove zebra mussels. It was to see if we could use a low concentration to suppress the population, and then how long that suppression lasted for. And what we found was that it does work, and that it suppresses for a couple years. But with that ongoing continued reintroduction, I think they're back to a similar level to where they had been previously. But
okay. And then I guess the second part of my question is, studying biology, from an early point, copper sulfate used to be used to just kill anything aquatic. So, I understand that different concentrations will impact different things. So my kind of worry is how it can bioaccumulate, and kind of what are the health risks to humans?
Yeah, I don't know a lot about bioaccumulation of copper. We have
and it's fine if you don't. It's just things that I'm asking myself as I kind of think about this.
Yeah, I guess the effects to humans. So this is registered. It's safe. We were applying it. People were boating and swimming. It's considered safe for people to be in the water immediately surrounding treatment. And that that obviously the way that looks on paper is different than how that might sit with you as a person, right?
Yeah.
But when I think about it, one of the primary ways that copper is toxic to aquatic organisms is because of how it interacts at the gill site. And because we're not gilled and our skin is, a little more resilient than the gill surface, it doesn't affect us in the same way. So copper is actually approved up to 1.3 parts per million in human drinking water. I live in the city of St. Paul. We use copper to treat our drinking water for zebra mussels in St. Paul. So it is, it is used commonly in drinking water, and research suggests that it doesn't have any impacts to humans at this concentration. As with anything, I think if you expose yourself at a high enough rate, you'll see effects. But I think because we're so much larger and our biology is different, we don't see those effects. So.
Okay, I appreciate it. Thank you.
All right, thanks, Greg, for unmuting. To ask your question. We do have a couple more questions. One is from Lisa. She's wondering, how long is the treatment good for? 1 year, 2 years, so on and so forth?
Yeah, it depends on the treatment. There have been several of those full lake treatments that have done that like donut style approach that I showed, where they did a treatment and did it like once and have not seen zebra mussels return. So I guess it depends. The project that we did on Minnetonka was a suppression project. The goal was never eradication. you know, because it was just a part of a much larger lake, its goal never could be eradication, but there have been some small lakes that have treated and then not seen them again, and it's been a one-time thing. The suppression project, we saw a good reduction of zebra mussels for, I guess it depends what your threshold is, but you know, about 2 years was pretty substantial reduction. So.
Okay. Mark asks, what were the costs of the treatments you did?
Oh, I don't have that offhand. Yeah, sorry, I'd have to look that up. But I because this was a research project, it wouldn't be, I don't have the costs for like instances where lake associations paid to have a treatment done. Our work was research, and so a lot of like everyone's time was covered differently, and it was just the, you know, we weren't paying for the time or the equipment. We were just paying for the product, but I also don't remember what the cost of the product was.
Okay.
About that.
That was one of the last questions in the chat, so we do still have some time. If you guys want to continue asking questions, we do have time for a few more, so. I guess I have a question for you, Angelique. Did you, when you were doing the copper treatments, did you notice any impacts, like negative impacts on like your macrophytes or your macroalgae species, like your caras and muskgrasses at all when you were doing your research?
Yeah. So we did not monitor those.
Okay.
Just anecdotally, I didn't. There were no like apparent die-offs or anything like that. I mean, we were on the water all day, every day, but we did not strategically monitor that in any way. We did look at chlorophyll A concentration in the water, and that was a little hard to parse out. There was an initial change, but it almost seemed like we might have done our treatment at the same time that there would have been an algae bloom. I don't know. You know, it was a sample size of one treatment, so it was very hard to say much of anything. But we did see an increase in clarity, I guess, for what that's worth.
Sure. Okay, thank you. Yeah, I'm not seeing any other questions rolling in the chat, so I guess I just want to thank you for your awesome talk and spending some time with us today. So I guess we can move on to our next speaker then, Tyler Maselk. If you're on, if you want to start sharing your presentation, we can start a little earlier.
Okay.
Well, thanks, Emily, and thank you, everyone.
Yep. So our last speaker for the Zebra Mussel Forum is Tyler Maselk. He is with the Wisconsin Department of Natural Resources, and Tyler's going to talk about zebra mussel management options in Wisconsin. So take it away, Tyler.
All right. So, as mentioned, I am Tyler Maselk. I am a regional AIS coordinator, cover portions of west central Wisconsin and some northwestern Wisconsin counties with the DNR. Previously, I was an aquatic plant management coordinator, so very well versed in kind of what lake management occurs, specifically in the northwest portion of the state. And today we'll talk kind of, as far as Wisconsin-wise, what are some options for management you do have. Quickly turn off the camera. All right. So, kind of what we're going to discuss real quick. First and foremost, due to kind of any sort of management, specifically in lake, give a little bit of background on NR 107 and NR 109. These are aquatic plant management rules we have in the state relating to both chemical as well as mechanical and manual methods for inland bodies of water. And then kind of has been touched upon previously, we'll just kind of give a quick briefing on various options that have been done, tested, noted, just looked at outside of Wisconsin, kind of as you just saw in the last presentation. Current options that we have in Wisconsin specifically, as well as recommendations for water bodies that we have. Just kind of give a little bit of brief background on various DNR contacts, because depending upon where you're at, varies upon regional staff and who you ultimately would have discussions with if management of any kind is to be looked at, explored, and possibly pursued. And then we'll just end with some follow-up questions for folks if they've got oddball questions they have, just various things that they're curious about. So just a little bit of background. NR 107 is our chemical APM rule. This relates obviously to chemical applications in states, bodies of water in Wisconsin. Regardless of any size to be looked at, permits are required underneath this code. And then we have to have herbicides, pesticides, algicides like copper that has to be registered by the EPA, as well as DATCAP. And then within that code as well, Wisconsin DNR has chemical fact sheets that we make. And we do ultimately have language that says if no fact sheet is present, then we could issue a denial for a permit due to not having that approved fact sheet. And then always, just a reminder for folks, always discuss with your regional staff before anything, even permit-wise, comes through. Minimizes any confusion and any steps along the way, and helps you guys ultimately moving forward as well, and kind of your next steps and plan of action for future management, monitoring, prevention, things along those lines. 109 is our mechanical aquatic plant management rule. So this relates obviously to mechanical and manual methods and water bodies of the state. Anything mechanical specifically requires a 109 permit. There is some certain exemptions related to manual methods. This primarily relates to riparian homeowners that manually remove aquatic vegetation within about a 30-foot wide corridor that gets them access to the water body that they're on. Removal of non-native and some invasive species can be done, but that specifically relates to aquatic vegetation and not necessarily dracenids like zebra mussels. And then obviously the reminder again of just contacting locally and our staff before doing anything. So kind of as it's been touched upon throughout the day and the last presentation we had, here are a bunch of various management methods that have been looked at across the state, between potash, the last presentation we had copper-based applications, equinox, benthic mats have been noted in other states, manual removal has been done in certain locations, drawdowns have been noted as a possible thing that can be done. CO2 being injected into water bodies has been looked at. Everything I've seen has been primarily tested in a lab-based situation, has not been applied to an actual lake at this moment. And then also biological methods such as the round gobies that have been known to eat zebra mussels in the Great Lakes, other noted stuff throughout the chat in the day, common carp, certain sucker species. So there has been other noted biological methods, but I always, with biological specifically, we would prefer obviously not to introduce anything before doing any sort of testing and studying. We have a great example with our purple loosestrife beetle that ultimately goes after that specific plant and doesn't harm anything else, but that may not always be the case. So with that, within Wisconsin, primarily anything chemical, and we do have approved fact sheets for copper-based applications, as well as CO2. We do have fact sheets for that, but ultimately it is not a recommendation and should not be explored, and it would be very hard to find any support from multiple regional staff to go ahead and pursue this. As each situation comes up, it can always be discussed, but we'll most likely not have support for it. With that also, kind of with any sort of management in bodies of water in Wisconsin, especially with the focus of today being kind of Northwest lakes, but as we've seen, we've kind of touched upon just northern lakes in general. We are a part of the ceded territory and definitely want to include whether it's local, tribal, as well as Glyphwick in discussions as well, just because they ultimately have an interest in the resources as well, and we all have it shared, so we want to go ahead and do what's best as possible for those individual water bodies. So kind of the four options that we do have in the state at this moment are manual removal, possibly benthic mats, which I'll touch upon a little bit later, drawdowns, which are very site specific, as well as just no management occurring. So within manual removal, kind of as I touched upon before, with the mussels obviously not being an aquatic vegetation, it would require permitting. And with it being kind of very site specific, you should obviously go ahead and do survey work beforehand to define high priority locations, because ultimately you want to go ahead and use your time as effectively as possible, as well as possible income or money expenses associated with it. So definitely getting kind of the best cost containment and prioritization that you would have. This option clearly being very labor intensive is best for localized populations. Depending upon your lake size, it can definitely be a very long endeavor. If you're over 1,000 acres, that can definitely be needle in a haystack sometimes if you're trying to go ahead and do individual tiny spots. So prioritizing those locations and using your efforts as best as possible would be the best way to go ahead and do it. Kind of the one question that still I have, as well as just a few discussions I've had with other folks within kind of region at this moment, is DASH. And DASH is short for diver assisted suction harvesting. This has primarily been a method used for your regional water milfoil management. And I got a couple slides kind of showing it, but primarily the best way to explain it is you have an individual scuba diver down at the bottom of a lake, and they're going through and individually picking aquatic plants. Specifically, has been targeted at your raised water milfoil in the past. To my knowledge, hasn't been done for zebra mussels at this moment, but it's a very laborious process as well, requires permits as well. It's definitely very expensive also. And with that, due to it being different than aquatic vegetation again, it might actually require, in Wisconsin, Chapter 30 permits due to disturbance of the lake bed in and amongst itself. So there might be additional permits associated with that as well. And here's just a couple photos kind of explaining a little bit more in depth. On the left-hand side here, this is an individual doing a survey specifically, not themselves doing manual removal, but the concept would still apply here. You're going ahead and picking individual rocks, looking at various aquatic vegetation, localized sites to go ahead and hand pick zebra mussels that are present in those systems. And on the right-hand side, this is ultimately what DASH would look like. It's definitely a very laborious process, works well in small localized locations. In large scale, definitely not a very applicable tool to go ahead and use. But I think at this time it can definitely be explored and discussed, and I would definitely at least try to cross all our T's and dot all our I's when looking at DASH as far as zebra mussel based management method. So another one that we have, I'm not aware of anything as far as in the state of Wisconsin at this moment of this occurring. There's been other states, I think Texas, there's an article out there relating to benthic mats being used in small acreages that were used ultimately on adults, and then they actually had eradication take place. That took place in about the mid-2010s. Not up to date on if there's been anything new on that specific water body, but it has been done in other places throughout the U.S. This, once again, like manual removal, also should have prior survey work done to define high priority areas. This is also, benthic mats can be expensive depending upon the material that you go ahead and use. Kind of the main use of it is ultimately not light penetrate to go ahead and suffocate out the zebra mussels in that case. And so obviously being respective of where you're doing it, being strategic with it, all play a factor into it. Size always plays a factor into it. I mean, depending upon if it's 1-2 acres in size, it's a lot of materials, definitely a lot of labor associated with it. Definitely a lot of coordination that ultimately has to take place prior to anything even being done. And then also in the state of Wisconsin, just to kind of be aware, we do have what are called sensitive areas, or has been updated now to critical habitat designations. These designations are areas that are defined by various DNR staff in the regions as areas of special natural resource interest, and a high priority, and with that comes various management recommendations, various protections that are associated with it. So that all plays a factor into discussions that can be done. And then with benthic mats, because it's covering a large area, depending upon the locations, it could be in an area that may be possibly good forage area and good protection for younger year fish. Might be possible spawning habitat depending upon the time of the year you're planning on doing such an activity. So with it, generally because you're ultimately smothering out a specific location, you can affect other species that may use that habitat. Depends obviously where it's located. It may have less species impacted and may have more, but ultimately it's to be expected that you have some sort of non-target impact associated with smothering out a specific location on a body of water. And here's just a quick example of what to kind of look at. This is an individual that has done it at their localized dock. You can see there's a bunch of native milfoils, things along those lines that are present. That might have been kind of their definition of a nuisance level. So going ahead and placing down the benthic mat, you can see that nothing is growing on top of that. And ultimately you would expect kind of a bare location and a smothered area underneath it. And it's non-selective at the end of the day as far as what it affects. So that's just always the reminder of being respectful of kind of what else is there besides just what you think the individual problem may be. So drawdowns is one that I'm not aware of anything in the state at this time, but it could be relevant for specific water bodies that have dams. If a lake does not have a dam, this is not even a consideration because you do not have one. And with drawdowns, I've been involved in one in the northwest portion of the state. It's a relatively long process. It takes a lot of time. There's a lot of planning and coordination associated with it, working with counties, working with tribal entities, obviously DNR staff, working with someone like a Greg, a fish biologist, wildlife staff, working with the DOT, as well as it may be a hydro dam also. So trying to figure out possible energy production, where it would come from, or the possible losses associated with it due to a drawdown taking place. They might have their certain stage heights that they have set out as far as where they want the water to be. And if they drop it down, say 5 feet, they would have their rough estimate of loss of energy production. And depending upon who you work with, may or may not be looking at supplementation or other means to try to find that income for that aspect of it. Once again, like everything else, this is a relatively time-intensive application. And historically, at least in Wisconsin, drawdowns have always been aimed primarily at Eurasian water milfoil or just construction, as well as rehabilitation of dams. So for the most part, the only species that has been tied to has been Eurasian water milfoil in the past. And there are some other side effects with it to kind of associate downstream aspect of it, but you do get sediment compaction on the body of water. Generally, you try to get decreased populations of the target species. In most cases, Eurasian water milfoil is definitely reduced, even though eradication hasn't taken place in those instances. And then just kind of always thinking about stuff non-target wise when it comes to management options, especially with drawdowns. They're generally associated with riverine-based systems. Always thinking of downstream impacts, any sort of sedimentation, erosion changes, timing, depending upon where you're at located, always plays a factor. Generally is done over the winter, so if you start doing drawdowns kind of mid to late September is when most of them start taking place, and then doing it very stepped of 4 to 6 inches roughly per day to allow other species, various amphibians, reptiles, to go ahead and hopefully not be distressed too quickly and allow them time to move off site. And we can definitely consider various mussel species that might be threatened or concerned also, which might be impacted by it too. So that's kind of always just kind of that background information you got to think about when you're going through and discussing these options. And then here's one up in the northwest in Douglas County. Minong Flowage specifically did a recent drawdown. They did roughly 6 feet, and this was kind of, as previously mentioned, targeted at Eurasian water milfoil-based treatment. And this is ultimately what you would expect. Most dams are associated with flowages, so finding woody debris, hazards along the way might occur. Ultimately, you want to leave those in the body of water and try to leave them as is. But this is what the visual perspective of it would be, as well as you still possibly have impacts within the flow of water. So that's always just kind of the background information to be considered. And then there's always kind of the one that people may or may not want to hear, but it's not having any sort of management take place. It's generally one thing that's been seen primarily throughout the state. Mackenzie chain, that's been the big thing as far as right now, is really no management has taken place. Bass Lake and St. Croix County has been the same way. They've had zebra mussels in that body of water for almost a decade or over a decade at this point. And for the most part, most bodies of water in the state take this route just because, for the most part, when they're found, it's more so at whole lake-based concentrations, and management efforts ultimately get relatively thin at that point. So kind of the big question that I feel like everybody always asks when they're going through these couple of options and when they hear various DNR staff provide them to them, done. So there's about 4 general things that can be done. There's monitoring, that's been touched upon with Paul and the CLMN. We've got education, we've got outreach, and we have prevention-based methods. So as far as monitoring comes, obviously doing the very passive approach of putting plate samplers or the brick at the end of your dock is one method for it, whether it's DNR staff, lake groups, county employees, various partners, contracted consultants going ahead and doing early detection surveys, just got interest in it, we want to kind of figure out what's on our lake, is a method for it. Having routine monitoring can be done, whether that's a lake group says, hey, every 2 weeks on Saturday, we're going to go out and do a survey of the lake or in these specific areas, like having a targeted monitoring approach, but having some sort of schedule based for it to ultimately keep up with it is one thing that's done. And then, as I just kind of previously discussed, targeted monitoring. So maybe people are aware of the habitats they prefer, such as kind of more rocky, firm-based areas, and then they are aware of where they are on their lake, and they decide to go ahead and look at those specific areas right away, or just kind of routinely, because they know that's habitat that zebra mussels do prefer. Education is another one. Can always continue with education. We're always learning stuff as time goes on, reaching out to various lake groups, talking at schools, trying to get kids involved, maybe get them aware. We all know they have busy lives. Various webinars, conferences, forums such as this are all educational based efforts for folks to go ahead and learn stuff from, what they can do, learn various science, growth, biology of the species, other impacts possibly that might occur from it. Maybe kind of what we've seen, maybe fisheries, is we're still just not aware of anything at the moment, but can definitely use more research on it. Outreach is another big one, where you can go ahead and work with local newspapers, doing newsletters like Lake Tides can be one, working with local news outlets can be another aspect of it. Social media, plenty of lake groups have Facebook pages, social media sites, or as well as kind of internet pages. So providing that to folks, whether it's through various aspects of it. You can go ahead and do mail, depending upon how they prefer stuff, emails, various events can be done as well as far as outreach events where you can go ahead and have a display for folks, provide information about individual species or just general across AIS or maybe regionally important species like zebra mussels. And then always kind of the big thing is doing prevention efforts. We have our kind of state standard, inspect, remove, draining, drying, not moving anything from one lake to the next. If you plan on going from one water body on a Saturday to a Sunday, making sure you're cleaning and decontaminating, or if you have time to go ahead and let equipment dry out before you're doing anything, when you're getting done at the lake, going ahead and trying to get as much water out of the boat as possible, getting any vegetation off of it, just doing any sort of best management practices ultimately to prevent any sort of introduction to other water bodies at the end of the day. And then always, regardless if you know the lake doesn't have anything in it or not, always treating every water body as if it does have some form of AIS present. We want to make sure that we just have these general baseline best management practices associated with what people do on a day-to-day basis, because ultimately these efforts will minimize any sort of chance of anything moving from one water body to the next. So with that, kind of want to get a little bit of a public service announcement. This is something that has gotten kind of curiosity for me, and I've gotten a few calls on it. So there's a relatively new product out there It's called a dock disc. I'm not sure exactly where the company is from, Minnesota maybe. And I've had a few individuals ask me, can they put this on their lake, because it ultimately is advertised as a zebra mussel deterrent. And there's various reviews saying it has and has not, things along those lines. But in the state of Wisconsin, as of right now, it is illegal to use and is currently not approved by DATCAP in the state of Wisconsin. So if anybody's seen these on their body of water, anybody asks someone and they say, hey, I want to put this out there. I know we got zebra mussels, but I don't want them on my dock. I'm going to go ahead and place these. I've got 5 of them or whatever it comes out to. Can go ahead and they can either reach out to me, or individuals on lake groups now are aware that this can't be placed in a Wisconsin body of water, and that information can ultimately be provided to them, so that way it's not an issue for them as far as possible citation in the future. So kind of as I've alluded to before in the past, always connect with DNR staff prior to doing any sort of management considerations. I know for me, I would rather have people contacting me all the time, every single day, to make sure that they're doing things right and they're not doing anything wrong from that side of it, and making sure that they have the best interest for the body of water at the end of the day. It's better to be upfront and kind of get things figured out and hashed out right away, versus on the back end and possibly having more damage than what it possibly could have been. So kind of here are my recommendations, as well as other DNR staff, as what to do within most parts of the state. Back to continue monitoring. I mean, DNR staff can't be everywhere, county staff can't be everywhere. Citizens obviously are on their individual body of water, and we rely heavily on citizens to ultimately go ahead and do some monitoring for us, just because not everybody can be everywhere. Continuing outreach and education. We're always learning stuff, always telling folks what we learn, any updated science, because as we've learned over time, things always change. We're always evolving, always learning new things. So always, always, always be willing to provide that outreach and education to folks, and taking preventative measures. You can never go too far when it comes to cleaning boats, cleaning fishing equipment, possibly cleaning vehicles, depending upon how much is brought in there. Even if it really comes down to false aspect of it, I mean, I can think of duck hunters full of vegetation. I know I have in the past, and doing their best due diligence to get any sort of sediment, any sort of water that's housed in waders, anything to go ahead and ultimately get rid of what was in that body of water and keep it at least at that specific location. And then as far as doing any actual management method, as of right now, since manual removal or no management have been primarily the main 2 methods that have been taking place in the state of Wisconsin, if you're going to do anything at the moment in bodies of water that have established species, localized manual removal would be about the only recommendation at this time, with the caveat of maybe you are located on a flowage with a dam, but then ultimately incorporating more comments and time associated with it. But this would be the specific method at this time to recommend to folks. And then always stay tuned for continued science and updates and research that's taking place. And then just kind of touching on various DNR contacts, there's a whole list of folks that ultimately we could go through. These are links if individuals want to get a hold of me. I would say just contact me via email. I'll just keep a list of who's reaching out, and I can send just a bulk email to everybody who's interested to figure out kind of lakes, AIS, APM, as well as fisheries staff that manage bodies of water in your individual location. Because ultimately, we want to get everybody on the same page as far as doing anything management-wise before we do any sort of permits approval. I mean, any sort of possible plan updates, creation of lake management plans, things along those lines. So that's always trying to make sure folks are reaching out to us versus doing something and kind of doing more harm than good on the back end. So with that, that's primarily all the methods that we have in this state currently. We're still learning stuff. Definitely as time goes on, things may change, but that's primarily what we have at this moment. Here's my contact information, email, phone. That's a cell phone number, so if you want, feel free to text me, name, who you are, water body. If you want to go ahead and talk or set something up, that's perfectly fine with me. I'd rather have people always contacting me and trying to get a hold of me to figure out what's going on and what they can and can't do, versus always being too late and we're trying to go ahead and catch up at the end of the day. So with that, relatively brief and short, not much that we can really talk about at this moment, but do we have any follow-up questions relating to what people can and can't do currently in the state of Wisconsin?
Yeah, thank you, Tyler. We do have a couple of questions that came through. The first one was from Maureen, and she was wondering if the DNR had any fact sheets for each of the methods that you were discussing, and where can the public reach those?
Okay, so we do
fact
have
sheets?
fact sheets related to chemicals. I have a link saved, so if people want to back to the kind of lake contact portion of it, if they have interest on it, they can just email me and I'll get a hold of them and send just a bulk email to everybody at the end of the day as far as where they can get that. And our aquatic plant management page ultimately kind of talks about various methods, drawdowns being one of them. Benthic mats are ultimately waterways staff. It's not approved through NR 107 or 109. And there's different pages associated with that as well that I can easily provide for folks, and then who their contact might be, because there's a fair number of waterway staff that can help out as well, and they deal with this when it comes to sediment as well as kind of lake bed based management issues from that aspect of it. So there's a number of links that I can provide for folks at the end of the day for where we can find that stuff. I mean, if you just type in just Wisconsin DNR Aquatic Plant Management, you'll get the general homepage, and that can list a lot of things and management methods for folks to kind of go ahead and just be curious about.
Okay, thank you. We had a question from Dale. He wants you to talk a little bit more about manual removal. If mussels have been found in targeted areas, can cement bricks or platforms be used as collection points for removal of mussels monthly?
Okay, so as far as kind of manual methods, correct. It's primarily been scuba, possibly snorkeling in targeted locations. I know the McKenzie chain has zebra mussels, but I'm not aware as far as if that's even occurred for the most part. It's definitely from that aspect very labor intensive. As far as placing structures, that would have to be permitted as well. That falls underneath that Chapter 30 aspect of it again, and working with waterway staff to place those structures in there. I think at that point, it just has to be discussed with the various regional staff if they're okay with that artificial reef, so to speak, artificial structure being there. But that's an option that could possibly be explored. And then kind of as we saw with other places, they can be removed and cleaned and then placed again as the growing season for zebra mussels takes place again.
Okay, thank you. Amanda asks, I thought NR 109 was specifically for aquatic plant removal. You need this permit to remove zebra mussels as well? Question mark.
Yep. Yeah, with 109 now, just due to the age of the code, it's almost 30 years old at this point, and is being looked at being renewed at some point in time. But it's been carried over that due to this being kind of an aquatic invasive species, it carries over into 109 at the moment. Even though it doesn't specifically lay it out, kind of Chinese mystery snails have been kind of the main, I guess, gastropod anyway, that's kind of been carried over into it, and people have been able to hand remove, and that's kind of under 109 at the end of the day is where it falls, the jurisdiction aspect of it. So that's where current management would take place.
Okay, thank you. I have a question for you, Tyler. We're talking a lot about manual removal. When citizens remove zebra mussels, and say they are living, how do they properly dispose of those?
So we're talking on things such as docks, correct?
Yeah.
Okay. So obviously what you want to do with those, I think we saw some photos from Big McKenzie as far as docks being pulled out and covered in zebra mussels. You'd want to go ahead and manually scrape those off. Pressure washers could be a possibility. I would still recommend just being diligent using manual removal at the end of the day, just so that way you're not getting as much kind of flying off the docks. And then going ahead and I've seen various methods just going through literature of people leaving it out in the sun to dry and desiccate as a possibility. Leaving them in enclosed bags and sitting in the sun could be an option as well, just so that way possible things like birds and that aspect of it might not be able to go ahead and grab a zebra mussel and possibly disperse it to another water body at the end of the day, because that's always kind of an oddball vector that sometimes isn't considered. I would be hesitant to take it to landfills and just placing it open in those situations. Back to oddball chance of something might find it close up to a body of water, may or may not cause an issue for somewhere else at the end of the day. So that would be my recommendation for the most part is scrape them off, bag them, keep them enclosed for multiple days outside. Make sure that any chances of other animals and wildlife getting to it has been rectified. And then after a few weeks, I'm very diligent, after a few weeks, going ahead and then taking it to a local landfill and keeping it in a bag.
Okay, thank you. We still have some time for some questions. I haven't seen any come through the chat since Amanda's question, so feel free to submit those questions to Tyler. And yeah, we still got time. Okay, Sandy Swanson asks, any Wisconsin lakes using copper sulfate for treatment at this time?
At this time, not that I'm aware of, at least when it comes to zebra mussels. Down in southern Wisconsin, there was a copper-based treatment related for starry stonewort, I believe. And those efforts, at least for that species, were not effective. But that is the only location down in southern Wisconsin that I'm aware of anything copper-wise actually applied in lake in Wisconsin.
Okay. Cheryl asks, is there any effort underway or plan for DNR to investigate the potential to authorize copper treatments for zebra mussels in Wisconsin?
I think at this time, I'm not aware of individualized Wisconsin research being done to further. The answer ultimately would be in certain scenarios, kind of what we saw in Minnesota being done. We're looking at obviously research that was being done, like Angelique's, looking at impacts, long-term population trends, non-target impacts, things along those lines, and just trying to stay up to date with research. But I'm not aware of anything being DNR conducted at this time.
Sandy asks, anything new coming from our DNA?
Sandy, yep, eDNA studies, correct?
eDNA, yep.
Yep. I would say eDNA at this point, just kind of due to COVID taking place, is just kind of sitting idle at the moment. It's been done in the past in the Northwest. It's been looked at Lipset Lake. The Kennedy chain's been done. I actually partook in some of that in 2019. But at this time, at least for zebra mussel specifically, it's just kind of sitting idle at the moment.
All right, well, it does look like the questions have slowed down a bit, so I just want to thank you. Oh, one more. Here we go. Mark asks, since it looks like no management is probably the way to go for us on Wappo bear trap, is there information available as to how do we live with zebra mussels?
I believe the Invasive Mussel Collaborative has a fact sheet, and I know I have one somewhere else. I can't remember exactly who it's from specifically, but there is kind of a what to expect with zebra mussels fact sheet that is out there. I can dig that up and provide it to you, Mark.
And we did, Colton and I also put together a kind of living with zebra mussels handout, and we can be sure to share that. And we also found another one, I believe it was through the U of M. That was really nice.
That's the one I was thinking of.
So I'm not sure if anyone does have any more questions that might kind of float in, but just as things are slowing down, before we do adjourn, I wanted to thank everyone for joining us today for the Zebra Mussel Forum. I, again, especially wanted to thank all of our presenters for sharing their expertise and making this event possible. And I know we had a couple questions about the recording. And so, yes, we did record the event today. And we are going to plan to send that recording out to everyone that did officially RSVP. So if you did an RSVP, we just don't have your contact information. So make sure to get in touch with myself or Colton, and we'll be sure to share that out with you. And, you know, some of these other handouts that were mentioned, maybe we can get a hold of those and share those at the same time as well. So with that, thanks again to everyone. Thank you, Emily, so much for moderating for today's session, and have a great rest of your day.
Yeah, and I would like to say thanks to everybody too, and thank you to everybody that was listening in, keeping your mics muted and your videos off and asking awesome questions for our presenters. So take care and have a good weekend.